Hello guys, how are you doing? My name is Dave Partner, and today we are going to be creating a tutorial on Python. Python is like the easiest programming language in the world, and one of the most widely used and most powerful programming languages. If you know Python, you can go into data science and artificial intelligence, web development, and so on. So the first thing you want to do to learn Python is to download and install Python. I'm using a MacBook, so if you see something different from what I'm saying, it's probably because you're using a Windows system. So to download Python, go to python.org/downloads, or just go to python.org and click on the downloads button. Right now, here you see that we have Python 3, so you click on it. And as you can see, there are versions for different systems. You can download the one for Windows, Linux, Mac OS. In this case, I'm using Mac OS, and my Python is downloading. So basically, once your download is done, you have to click and install it. So in my own case, I'm using Opera browser for this download. So this is where the download section for Opera browser is. So I'll click here, double click and install it. If you're using Windows, if you're using Chrome, then this is where you're going to install it from. If you're using Chrome, it's at the bottom of your screen. Look at mine, at the bottom left corner of the screen. So that's where you click to install it. Okay, so the installation is on right now. I'm gonna ask you all these questions. Just next everything. So next. Next, and agree, stop, and then ask you password, and then install. So if you're using a Windows system, it's roughly the same thing. Just click next, and you're done. So now there are two versions of Python. There's Python 2.7 and then Python versions that are above 3. Now the latest one is actually the ones above 3 at the moment, 2021. Now 2.7 is kind of the legacy version. If you are taking any tutorial on 2.7, you should upgrade to 3.x. So we're running on 3.10 now. But the thing is, in the future, you could see more versions. So Python is installed and in our system already. We just need to drag it into the applications folder. It doesn't matter if your version of Python is slightly above this. It doesn't really matter. It's just the same thing. Alright. So the installation is done. Click close, and then saying whether we should move the stuff to trash here. So the installation file is moved to trash. Okay. Now it has automatically moved itself to the application folder. Otherwise, it might prompt you, if you're using Mac, to drag to applications folder. If you're using Windows, Windows does this automatically. You don't have to worry about dragging anything to anywhere. Okay, so the next thing we'll have to do is to install a text editor for Python. Alright, so we have to visit the website for PyCharm. So the most popular text editor for Python is called PyCharm. So we'll go to jetbrains.com/PyCharm. Okay. So that's the company that built one of the best text editors. So I made a mistake here. PyCharm. Okay, this is PyCharm. You click on download. Now there are usually two versions of PyCharm. The first one is the professional, where you have to pay. And then there is the community edition. Now my system is already selected properly, the processor of my system, so don't try to change this. Okay, to detect what's in your system. So I'll click download. So the community version is the free version. As you can see, it has started downloading. One thing you have to know, just a tip, is that Opera download is about 10 to 20 times faster than Google Chrome download. So if you're trying to download any of this on Google Chrome and it's taking time, download and install Opera browser and then try to download again. You'll be amazed at the speed. And then Opera browser can be downloads can be paused, unlike Chrome. If you pause a Chrome browser download, it stops, it spoils the file. But in Opera, if you click a download, if you click pause, you can always start it any day, and you can pause a download so many times. So our download is complete now, and you can see the click to start, and it's asking us to drag into the applications folder. This is a weird thing with MacBook. Alright, so in Mac, you have to always drag installations to applications folder, otherwise you find it hard to find the installed file. Now, but in Windows, it just works automatically. So once you've installed PyCharm, we have to go and start it. So in Windows, you go to your start menu and look for and type PyCharm. Alright, but in Mac, we just have to go start it. From applications folder, we look for, let me go to the more familiar one. So you click on the applications here, and then we look for PyCharm. Type PyCharm. Probably the last time we installed. Look at it here. Double click and close this. So once it starts, we're going to do a very basic configuration. I prefer dark themes to lighter themes, so we could switch to a dark theme, and so that it doesn't hurt our eyes. Now sometimes you might see this one on Mac saying that PyCharm is an app downloaded from the internet, so just click open, okay? Allow it. I confirm that I've read and continue, and don't send. And we're good. It has opened. Remember that your own might have a slightly different design if you're watching this tutorial from the future. So, but the most important thing on the screen is that you have new projects, then you have open, then you have get from VCS. So instead of creating a new project, I want to customize it. Make sure I show you where to customize it from. So in customize, you see that there are two themes. The first one is Dracula, and then there are like two extra, okay, and even three extra themes. Now the interesting thing about this is that this theme has already taken my default theme for the MacBook, so I don't need to set anything here. So another thing is the font style. I prefer to have it bigger because I'm making a tutorial, okay, and every other thing is perfectly fine. And then we'll go to projects and click on new project. So it's asking us a new project, and another thing is it's asking the interpreter. Okay, here is where our PyCharm projects will be saved inside our MacBook PyCharm projects. Okay, and now here it's asking us for interpreter. If you click this drop down, you'll see that there are so many interpreters. If you have a MacBook, just know that Mac comes by default with a Python version installed in your Mac. So as you can see, it comes with the default Python version, but we are using a higher version, and PyCharm has smartly and intelligently selected the higher version that we're using. Okay, so every other thing here just is okay. Don't try to adjust anything, just confirm that you're using the latest version of the interpreter. Now we're going to name our project something. Instead of Python project, we're going to name it something. So what do I call it? Let us call it Lion. Okay. And once we're done, we come down here and then click create. Okay, so once it has created, we have to start with a file. We create a new file, and okay, so there are all these pro tips that come with PyCharm. You can close it and take it next time. So this is not a pro tip tutorial. So here, one thing you notice inside our project folder is that it has already created a file for us. Okay. Another thing you can do is to create your own file. You can right click new file. I want to call it out.py. Okay. Now we have a new file. So that's exactly how to create files in Python. Okay. Let's write our first Python program. So we can usually the first thing you write in any programming language is to print to the screen. Okay. It's to print to the screen. So I'm trying to zoom this. Okay. Print. I would have said hello world, but since we're coding Python, I say hello world. Okay, that's like a hello, hello to the Python world. Okay. So now Python is very much space sensitive, so you need to know where all the spaces are. That's just Python for you. All right. The first thing you notice here is that there is an underline. If you hold your mouse above it, it's going to tell you why it's underlined. It says no new line at the end of file. So just hit an enter and it's gone. So you click save, Ctrl S on your keyboard to save the file. And then at the top of the top menu, alright, just click on run. So in Windows, this will be inside the app. So you click on run and they're saying, do you want to run main.py? Okay, let's run. And then it asks you which file you want to run. So I want to run app. Click OK. And at the bottom of the screen, you notice that a command prompt pops up. And then inside the command prompt, you can see very clearly that it has printed hello world. Okay. So now the next thing we're going to do is to print a triangle on the screen, just to give you an idea of how the whole printing thing works. Okay, so alright, so let's try and print something else. Let's try something else. So here, right click, new file. So I'll say I want to print a new shape. So I'll say triangle. Okay, so oops, there's a mistake. The triangle is supposed to be triangle.py, so we'll look for rename. So once you right click here and refactor, you say rename. So once you say rename, triangle.py. Okay, refactor. And now we have triangle.py. Okay, so the next thing, just double click it. That's open. So the next thing we want to do is to print a triangle. So do print. I think I should expand the text. Okay. So print. It should be easy. Let's say I do 1, 2, 3, 4, 5, 6. Okay. So this pipe bar is the bar above my enter key. It's above your enter key on the keyboard. So I'm just going to copy this line and then Control C, Control C, Control C, Control C. Okay, so here I'm just going to reduce the space. Alright, here just going to reduce the space. So here and here. So instead of this, I can put underscore. Alright, so now I have this. We save it, Ctrl S on my keyboard to save this file. And you know, we could run this in many ways. The very first way we ran this was from up here. We clicked run and we clicked run. But also on this PyCharm, you could see from the top right that you could just click run here and you select the file. Okay. So I'm just going to use this one at the top here and say run. So once you run a file before, it's going to show up here. So the one, ask us which file, we say run triangle, and look at here. So the first thing you notice is that here it has printed the triangle. Now what do we do? What happens if we take one of the lines and place it somewhere else? Okay, so I highlighted it, press Ctrl C on my keyboard, or just right click and copy. Okay. As you can see here, it's telling you the shortcut Command C on the keyboard. Okay, if you're on Windows, it's Control C. So I'll save, which is Control S. Okay, so once it's saved, up here, and if we run it, as you can see, I can now run it from here. If I click Run, keep your eye here. You see what happens? It has changed it. Okay. So Python basically runs your code line by line, alright, in order. Procedure, that's how the parser passes it. Alright, so let's look into the next tutorial where we are going to look at variables and try to understand variables in Python. So to be sure that you really understand this, we are going to try and print another shape. So first of all, let's redo what we did here. So Control Z on your keyboard or Command Z, okay, and we're back here. Good. So the first line I want to print is print. The text says triangle, okay, and then we'll print empty space, okay. So let's run. Click Run. Keep your eye here. And there's a triangle, there's empty space, and then this. So let's do another empty space and print empty space. Oops. Print empty space, and then we do another print. Let's say rectangle or square, whatever. So how would you print a rectangle? I would like you to pause this video at this moment and try to write the code that will print a rectangle for you, but I'm going to write mine now, alright? Pause this video, try it, and then compare with the code I wrote, okay? Alright, we'll do it here. I'm just going to say a print. So how would you print a rectangle? The first one is to print underscores, alright, and then the next line is to print pipe bar. It is called a pipe bar. You hold down the shift on your keyboard and type the button, click the button above your enter key. So this is a pipe bar. So we are going to have a pipe bar many times. So I'll do pipe bar, hit enter, hit enter, hit enter. And then the next line, I copy this line again to duplicate it and paste. And here we also need to move this much spaces. I think I have to add more here, okay, to make it a full rectangle. So here we move this much spaces, and then we do another pipe bar. So I actually think copy this line, paste, and then copy the first line and paste. Okay, so if I click save, Ctrl S, I can now do run. You see, so it says triangle space rectangle, no space. So remember that I put space here, but that space is not showing on the console. That is to show you that the empty space is not counted unless you create it. Okay, so rectangle. So how would you write something inside this rectangle? Can you think about it? Pause this video and try and write a rectangle inside here. Okay, this is how I will do that. I'll just remove some of the spaces and write rectangle and add extra space and save. Then run. You have rectangle inside. Alright, one thing I can do is, instead of changing this to triangle, I would call these shapes refractor and rename to shapes. Okay, refractor. Alright, another thing we can do is to create a new file. Alright, so let's look at creating a new file. So right click here and new file. We call it variables, variables.py. Okay, it is created, variables.py. So if this is your first time of programming, just know that a variable is a way to store some data that you can reuse later further down in your code. To be a good example of this, let's write 3 or 4 sentences. So I'll do print, and of course zoom this. I think I should set the font size permanently. I'm just trying to increase the font so I don't have to manually increase it in every code. So PyCharm preferences, and once the preferences pull up, you don't have to do this though. So go to editor. Don't have to do it. I'm doing that because I'm making tutorials font, and then the font size is at 13. I think I have to put this at 16. Okay, 17. I think this is okay. And I'll click apply at the bottom of the screen. Apply. And okay. So when next I restart this IDE, it's gonna be much bigger font. Alright. So let's print some statements. Here, let's say the quick brown fox jumps over a lazy dog. So this is a sentence in English language that contains all the alphabets, in case you don't know. So let's print our second one. But the lazy dog called his little or his 2-year-old brother. Old brother. And the 2 dogs started chasing after the quick brown fox. So basically, I'm trying to write as much sentence as possible while repeating some things. So if we print here, if we decide to run this, so remember how to run. At the top here, you click run, and run, and select variables. And here it says the quick brown fox jumps over a lazy dog, but the lazy dog called his 2-year-old brother, and the 2 dogs started chasing after the quick brown fox. Now the thing is, here I want to put a comma here so that you can understand some things. This way. Okay, so what if we don't want the color of the fox to be brown? What if we wanted to change it to red? Okay, what we do is we have to read through this code and find every instance of brown and change it before saving. This is not good. So imagine you have 10,000 lines of code and you want to change an instance of something. You have to read through your 10,000 lines of code all over again. No. So what you're going to do is, let me do Ctrl-Z or Command-Z on my keyboard. We can create variables and use the variables as a store of value. We store the different things we want to change in this code, so we can only change it in one place and it appears everywhere in our code. So how do we create variables? You just write it. Okay, let's say animal name. Okay, animal 1 name. So this is how you create variables. You can just call it animal, okay, or whatever. If you are going to join 2 words, it's advised that you put underscore. So I can say animal name 1 equal to fox. We're dealing with a fox. Okay, and animal underscore name 1 underscore color. Okay, so a variable is basically you make up any name, and then you assign a value to it. But you want a generic name, so you can use it somewhere in your code and it will mean something. So the color is brown, and then we can do the same thing for animal 2. Animal to age. We change this 2-year-old, okay? So you can say the second animal age to equal to 2. Alright, so we've created this variable. Now we have to pass this variable into our code. Alright, so we find where we need to change the name of this is a fox, right? Brick brown, okay, brick red fox, and then there's another instance of fox. So what do? Well, first of all, close the string. Alright, so we make sure that it's this, and then here we'll have to add that variable, and this is how we're going to do it. We'll put 2 plus sign and put the variable inside, and the variable we're dealing with is this. Alright, so this is how it works. So if you want to add a variable, you have to use a plus sign. If you're coming from JavaScript, you're already familiar with this system of adding variables, because this is how JavaScript does it. So basically, you define a variable, you make sure that you close off the other places, and then you use a plus sign to add it. Okay, so we're going to do exactly the same thing any other place that fox appears. Alright, so we'll copy exactly the same thing. I think let's run it first. So click run, click watch here. It says the quick red fox jumps over a lazy dog. Now one thing you notice is that we did not put space here, and we did not put space here. Okay, so if we save and run again, it says the quick red fox. You see the spaces are there now. Alright, so actually this space doesn't count. This space doesn't count. Alright, the space that counts is any space inside 2 quotes. Okay, inside these double quotes, that's the spaces that count. Any other thing you put here don't count. Alright, so now there's another fox here. It said the quick red fox. Okay, but before we go ahead, let's change this to cat. Save, run. So we'll run. What you see here is the quick red cat jumps over a lazy dog. Okay, and then at the end of the day, it still says fox here. So what we're going to do is to copy. Notice that I copied the spaces too. Okay, and here, let me drag this, and here we'll paste. Control V. So I used Control V to paste, and you can see it. So I copied the spaces, but most importantly, we don't need any extra space at the end, do we? No. So we eliminate that. Okay, so if we run again, keep your eye here. We run. It says the quick red cat jumps over a lazy dog, and the 2 dogs started chasing after the quick red cat. See? Now, if we put extra spaces here, what happens? Save, run. See, the extra spaces appear. So only spaces between dots. Now you may ask yourself, what happens if we put the spaces outside? Save. Number one thing is, Python is going to warn you. You can't put more than 1 space outside. So if we run, it doesn't even show. You see, it doesn't show. So usually outside, you just want only 1 space extra. Now another thing is, let's insert this other one. So we have animal color. So instead of red, we put I pasted what I had before, but then I can change this to animal color. Now what do you notice? We have 2 quotes, then we have a space, and then we have our variable inserted, and then we have an empty space. If we don't have this empty space, see what's going to happen? If I run this, nothing will change. Okay, to change to brown. Okay, if I run this, so it's the quick brown cat jumps over the lazy dog. Beautiful. But what if we don't want a space? So if we don't want a space, I'm going to copy out plus sign and space. Save. So now we have 2 variables side by side. So when you have 2 variables side by side, you still use a plus sign to join them. So we have the first one, plus variable, and the plus variable. What happens if we run this? Can you guess? So if I run, what we're going to see is the quick brown card. You see there's no space. You see? So that's how to add space. If you want space anywhere, you have to add it. But you can't add space, for instance, here inside this variable. You can't do something like this. No. Because you see there's an error. It has to be a full variable. So Ctrl Z on my keyboard. Ctrl Z again. Good. Now what of age? We can do the same thing for age. So I'm just going to copy what I already have. In programming, you have to do a lot of copy and paste, otherwise you have to type to your left hand. So I'll remove this two and Ctrl V. Okay, remove all the extra spaces, just one space needed, and here just one space needed. And the variable, I'll copy it, and here I'll paste it. Okay, so what you have now is exactly this. So if I just click run, it's going to say the same age too. Now here's the fun part. What if we want to change the age? What if we put 28? So it's 8-year-old dog, and click save. I don't think there can ever be 28-year-old dogs. The average lifespan of dogs is 14 years. So if you see a 16-year-old dog, that dog is really very old. Okay, so you have animal name, and it works well, 28. So that's the beauty of variables. But so far we're just putting only one type of variable. For instance, we're using cat. Now, have you ever wondered what happens if we remove this? If we remove these quotes and run this, you see there's a problem. So let's talk about variable types, so you know how best to use what you want to use at the time you want to use it. Now, before we continue, at this point I want to mention that I want to show you a place to get the full list of functions and things you can do. Before I continue, just go to google.com and search for W3 Schools Python, and then you click on that. Okay, I would have referred you to the core Python documentation. If you typed Python, but I believe it's too technical for you at this moment. If you type Python documentation, and then you click on Python, the version of Python you're working with, then you click on library reference, okay, or language reference. So if you click on language reference, you look for what you're working with. For instance, now we're working with strings, and then you can Control F or Command F on the keyboard, type strings. Okay, so as you can see here, there are so many things you can do, but it's too technical. I find it easier to refer people to W3 Schools. Okay, so let's go back to Google and look for W3 Schools. W3 Schools Python, and click W3 Schools. Now, what you notice here are different topics you have to cover to be able to understand Python. Now, you look for strings somewhere here. Strings. Okay, if you click on strings, you will see subtopics. So there are about 7 subtopics in strings. So different things you can do in strings, which is what I want to cover now, but not exactly as they did it. But in case the proper way to learn is after I cover every topic, you come here and confirm that I've actually covered every. And usually there's no tutorial that will teach you everything, even W3 Schools. So they highlight the major ones just to show you how things work. But as you get onto a proper live project, you will see many other use cases that were not covered in any tutorial. You have to go to the documentation directly, okay, or you go through Google and famous Stack Overflow. So here, let's get back to our code. So we're still coming to numbers like this. Here, we're still coming to numbers. Remember, we changed this to a number and it gave us error. So we will return it to strings. We'll come to numbers in the next 2 tutorials. So here everything works, and now we're going to work on string manipulation, how to work with strings. So I'll right click on line and new file. I'll call it string underscore manipulations.py. Okay, string manipulation. string.py. Good. The first thing we want to do is to look at what a string is. A string is any data or information you put inside double quotes. Okay, so I can do print. Obi is a boy. Okay, the boy's name is Obi, and you can see it now. Another thing I can do is, using the concept of variables that we had before, what if we set this to a variable above and say boy or sentence equal to Obi is a boy, and here you can say print sentence. Alright, so if I run this, sorry, it's still running the variables. We have to switch to string manipulation. So usually we go to the top, click on run, and now there's a shortcut for run. In case you're on Windows or anything, you can press the shortcut, but I like to use here because I'm running a tutorial, string manipulation, and it says Obi is a boy. Okay, cool. Now what if we want to add another variable into it? So just like we did before, we can say gender equal to, choose a gender, let's say girl. So here we can remove Obi is a space. Okay, if we print this, it's going to say Obi is a. So now we can now link this and use plus gender. Guess what's going to happen? It's going to join two of them without spaces because there are no spaces at the beginning. So let's run. It says Obi is a girl. Okay, there's space here at the end. Okay, cool. Alright, so actually the order doesn't matter. What if we put this here and run? Still says Obi is a girl. Interestingly, what if we put this under and run? It's already underlining this because it's trying to use a variable that you are yet to declare. You declare after usage. So the only thing that can work like this is functions. Okay, but variables, no. It's gonna throw an error. Okay, you are using it before declaring it, so you have to always declare it. Okay, so here you can say we've now known. So this plus sign is called concatenation. All right, in strings, concatenation. That's what it is called. Okay, this plus sign is used to join two strings together. Okay. Alright, so let's try something else. There's something called a backward slash. The backward slash is the key above your return key in your keyboard, alright? Your enter key on your keyboard. So if you press it once, it shows you. So if you include it, it means escape, okay? This is escape. Okay, that's what it means in Python and programming languages in general. So this backward slash, it means that anything you put in front of it, Python will not treat it as, will not try to process it. It will treat it spatially. That's what it means. Okay, so let's say we do Obi-n. Okay, you see the color has changed, showing that Python understands that what you mean by this. All right. So n means new line. So if I run this, it's gonna be Obi. Then it will move the rest of the sentence into a new line. It's a go. Okay. Now here's another thing we can do. What if there's a space here? What if we put a space here? Save and run. You see the Python, there is nothing after the backward slash. So Python sees that as a normal part of the sentence. Okay. So that's how you do backward slash. What if you do double backward slash? Can you guess what it is? Double backward slash. So the first backward slash escapes the second backward slash. You see, so we now have only one. So that's an escape for you. You can escape so many things just to convince. For instance, here, let's say I want to use a quote. You know, strings, you have to include strings inside quotes. So let's say I'm writing a sentence that involves a quote, like I want to quote somebody else, what somebody said. For instance, I can say, and he screamed, "Get behind me, Python." You see, something like this. You see, there's an error because Python considers this sentence complete here, and then it doesn't know what it is. This is not a variable or anything. It's confused, and then it sees another double quote. So what do you do when you want to use a double quote inside another double quote? In Python, you just escape it. You put the backward slash, and it escape the first one, but the second one still has issues, so you escape the second one to escape. So once you escape anything, Python sees it as a normal part of the sentence, and if we run here, it's gonna say, and we scream. You see, it's now printed, "Get behind me, Python." Okay, so there are string functions in Python. What is a string function? String functions. Okay, so what is a function? A function is just basically a block of code that somebody has written that does just one thing, usually. Alright, sometimes a function does many things, but mostly it's advised that a function does just one thing, and somebody has written it. You just, or you may be the one that authored it. You just take it and apply it to something else you're working on, and then it does that one thing for you. A good example is that we can write a function that adds any two numbers. So we are getting to functions further down the video. Okay, so we can add a number that we can write a function that adds any two numbers we give to it. So if we're building a calculator, for instance, and we have to add two numbers, we don't have to write the code all over again. We just call the function. Now, with respect to Python, Python already has some inbuilt functions that came with Python. Okay, there are inbuilt functions that came with Python, and let's look at them, the ones that came specifically for strings. And that's exactly what you see in wtrace codes under Python, under strings. Okay, you'll see a number of such functions. There are many, but wtrace codes covered only 6. Okay, I'm just going to cover a handful just to give you a general idea of how that works. Okay, so here, let's look at some string functions. The first one is to forcefully convert a string into uppercase. Okay, remember that this gender is girl. Okay, and what if we want to convert it into capital letters? We'll do the upper. So whenever you're calling a function in Python, you have to put these double brackets. Alright, save. Now it's saved and we run. What it does is, and his screen, "Get behind me, Python, go." You see, it's now in uppercase. What if we want to convert something that is already in uppercase to lower? So let's say part of our strings is in uppercase like this. For this sentence, we do dot. Dot is how you append a function to it. I'll say but lower. Okay, and we run. And what do you see? It forces everything, including the Python, to enter into a lowercase. Do you understand now? So that's how the upper and lower works. So what if you're writing a code and you want to check whether a string is already in upper or in lowercase? For instance, people's passwords. Somebody could make a mistake in their password and they don't know that their caps lock is on and they're typing their password in capital letter without knowing. So in Python, you can use your code to tell if the text they sent is in capital or lower case. Some other time, you might require a password to have at least one uppercase letter. So the way to do that in Python is to just put is. If you do is upper, okay. Let me remove this so that I'll work with one. Let's just work with one. Okay. We're working with gender, and we want to check if gender is upper. So this will return true or false based on whether the text is upper or lower. So here it's upper, and we run. What will it give us? It's going to give us false because it's not upper, right? So it says false. Okay. If we want to check whether it's in lowercase, we do it's lower, and save, and run. And it says true. Beautiful. Now, what if one character is in uppercase? I like to try a number of things in programming. Okay, one character, say, and this is how to learn programming. You try things, you ask yourself, what if this, what if that? Then you try it out and see what happens. So, one character is in uppercase, we run. Interesting. It's asking us, we're trying to check whether it's in lowercase. So, this function actually checks whether it's all in lowercase. So, if there's at least one word or character that is in lowercase, it's going to give you false. Another thing we can do is to do replace. Okay, string replace. What if we want to replace a certain character inside the string? So let me return this to GIRL save. Okay, we want to replace a certain character. So let's say we want to replace L with another with G. All right. So first of all, you mention what you want to replace. We want to replace L with what? G. Or let me not say G, Z. Or X. Okay. So we want to replace L with X, and we run. Boom. You see, it's replaced. Now another thing we can do is what if L doesn't exist in the string? Let's say ask it to replace Y. We know there is no Y in the string. So replace Y with X. What's going to happen? It doesn't do anything because there's no Y there. Okay. What if we say the same thing here? Let's use the longer sentence. So here's the longer sentence, and we say replace the word screen with X, or change it to shouted. Okay, it says and he shouted. So you can replace entire words. Now interestingly, what happens if we do screamed and get? Okay, see there's a problem. There's no screamed and get are not two words together. There's something in between. So it couldn't find this and it couldn't work. But what if we do key screen, these two, and you see it changed, saying and shouted. So this is how replace works. Now we're going to look at length. If you want to check how long a string is, this string is 1, 2, 3, 4 characters long. What if we want to change it? We look at a different type of function, which is in Python. It's called len. So if you want to check the length of a string, you put len, okay, and you run, and the length is 39 characters make this up. So in this case, if we change it to gender, and save and run, it says 4. Okay, the next thing we're going to look at is to find the position of a certain character. So Python treats this string as an array. We're going to get to arrays in the future. Basically, it assigns a number to each string, and that number has to start from 0. So for instance, at position G you have 0, at I you have 1, then 2, 3. Okay, so if we want to get R, which character is at position R, we use 2, right? Okay, so let's see. Let's remove this, and let's remove this. And say page.index. That's how you find the position of something. Not index now, but let's say we want to find something at position. Oops. Okay, gender at position 0. Let's start with 0. 0. So what do you think it's going to print? It's going to print G for us, right? So G. What if we do at position 3? So 0, 1, 2, 3. So that's array index. Most programming languages, their array index starts with 0. So if you go to an alien planet somewhere, one of the first things you should check about those aliens in some sort of Andromeda galaxy is where they start counting their array index. Okay, so on this planet, most programming languages start with 0. Okay, and gender with run, and it gives us L, which is the last one. So what if we do 5, something that we know that is beyond, right? Or it gives an error. Alright? An error. What does the error say? It's traceable. Most recent confluence of the file form of the print gender index error string index out of range or Stack Overflow. Alright? So it's out of range. We are firing out of range here. Alright, I think we covered basically most of the some of the string manipulations, and we're going to go to numbers now. So I'll change this to something that works. We're going to go to numbers now. Alright, like I said, if you come here, for instance, you could see other ones, right? I did not cover string methods. I covered it. Only one I did not cover is slicing. So go there, check it out. Okay, scroll through this page. It's free. Scroll through the page, and you see there are many: capitalized, caseful, center, count. Find some of them repeats, like count. We'll do the same thing as string length. Okay, specify the number of times a certain item occurred. So if you click on it, you will see a better explanation of the word. Look at count. What does count do? If you tell it to count where apple, how many times apples appeared, it's going to give you a number. So for instance, if we come here and say which word repeated twice, so let's say on the screen, let's say he, again he. So let's say the word he appeared many times, and we do sentence. Let's count, and then we do he. So what is it going to give us? It's going to give us 1, 2, 3. Okay, so we do it like this, and boom, gives us 3. So if you actually calm down and go through the documentation of W3 schools, you will see a whole lot of a whole lot of functions. Is it a number? Is it alpha? Is all the characters and alphabet, or do you have numbers there and stuff? Is it digits? Is title? Is a whole lot to say. So try each of them so you get an idea of what they do. Some of them can help you split cottage string into 2. Alright, let's look at numbers. Yes, remember what I told you at the beginning of this tutorial, that or in the last tutorial, that we're going to see how to concatenate numbers to strings. So let's say we have another variable that we call age, and I'll say that her age is 24, and here let me put this underneath. Okay, so let's say the age is 24, and we try to use age here, and let's say we want to use age. Okay, this is how you concatenate. Alright, it looks good here, but when we run it, we're gonna see a problem, because this is a different variable type. This is an integer, and this variable type is a string. Okay, so they don't work together unless you tell Python to forcefully convert this into a string. So it's gonna still be 24, but Python will forcefully put it in its own internal quotes, so that it's going to look like a string. Alright, so if I save this now and run this way, you see it runs without errors. So if we're going to leave something in a string, many times you're writing programming, you will deal with variables like strings and integers a whole lot. So how to tell Python to forcefully, they call it casting. Okay, how to tell Python to cast this integer into a string, we do str this way and save, and if you run it now, it runs perfectly fine. See? Oops, because sentence, no, this is what we should run. You can say this. Alright, right, so it prints perfectly fine. And can you tell why there is no space here? Of course, because there is no space here. And we run, and it runs. Okay, since full screen, Alright, let's look at numbers and some of the things you can do around integers, okay, and other types of numbers like double, floating, and a whole lot of other types of numbers. So here, let's create a new file and call it numbers. Numbers.py. Hit enter. So the first thing we're going to do is let's create a variable and call it whatever. So there's this number we want to calculate, and we have called it whatever. We can say for whatever is 24. Okay. I don't know why I keep using 24, but it's fine. And we're going to print whatever, and then we run. Oops, we have to run and select numbers, and it says 24. Good. What if we say 24 point is, let's say, run. You see, Python handles that exactly. But we can also do a basic math operation. Remember BODMAS. So here I'm going to write BODMAS. Okay, let's put it in now. BODMAS stands for bracket of multiplication, addition, subtraction, and this something called division. Okay, so this is what BODMAS stands for. So you can do all these operations in Python, but the first one I want to do is addition. So let me copy this out, and I think this is a good moment to teach it. Comments. You can add comments in Python. A comment is basically a piece of code or whatever you wrote in your code that you don't want Python to process when they are printing out or working on it. Okay. I'd like to separate the commenting to another video, but let me just chip it in here. That if you want to comment anything in Python, you just highlight it, and once it's highlighted, you press Command question mark on your keyboard, or Control question mark on your keyboard, and it's commented out. So that means if we run this code, the compiler will not look at this. Once it sees hash at the start of any line, it won't look at it. So I'll run it. It says the same 24 points this, that. So now let's do the first. Let's do addition. Okay. So let's say we want to add this plus 10. Okay. And we run 24 plus 10, 34. Then 0 point this, that. So see, it works perfectly. What if it's not a decimal? And we run. It says 34. So the next one is subtraction. What if we say 24 minus 10, and we run? It says 14. Good. The next one is division. 24 divided by 10. That's 2.4. Okay. Good. So what if we say brackets? Now this is interesting. What if we say 24 divided by 10 plus 5? Okay. What's this going to give us? 24 divided by 10, 2.4 plus 5, that's about 7.4. But let's see, gives us 7.4. What if we reverse it? 24 plus 10 divided by 5. 24 plus 10 is 34. Let's make it a round number so it will be easier to get. 24 plus 10 is 25 plus 10 is 35 divided by 5 should give us 7, right? You see, there is an issue. So what really happened? Can you tell what happened? Interesting thing. Remember when I told you about BODMAS? I told you about BODMAS. So you always have it in mind, because BODMAS is going to always guide you on how. This is the order in which Python will process most operations. Okay. Alright, it will work out everything inside the bracket first, and then if there's an off, usually you have only off in maths, okay, not Python. But then it will proceed to work out the division first, and then work out the multiplication, then addition and subtraction. So in this case, division comes first. So what does Python do? Python skips the first operation, okay, and starts with the second one that has a division. Okay, so it does this. It does 10 divided by 5. Okay, and then tries to work it out with this. So looking at this, you see that your whole code, your whole operation is just confused. It just gives you unexpected numbers whenever you run it, very unexpected numbers. So to avoid this, you use brackets, just like in maths, to determine, to tell Python which operation to process first. So if you put this in bracket, for instance, you'll see that our result will change. So now Python knows that it's going to work out this first. Okay, so 10 divided by 5 is 2. 2 plus 25 is 27. So this way, we are 100% sure that our Python will follow this method. Okay, but what if we want Python to do the first calculation first? What if we want Python to do this? And we'll run this. See, it's going to give us 7. So this is what we initially intended. So Python starts with the bracket. So what if we had this divided by, so forward slash is the equivalent of divided by in your keyboard in programming. So let's say addition minus 3. Okay, say minus 3. So what do you think is going to give us? Which of these operations will it do first? So we do run, gives us 24. How? Because let's say here it starts with a division, right? So this division says 10 divided by 5, 2. Okay, so division is off. The next one is multiplication. There is no multiplication here. Next one is addition. So what does it do? So it's 2 plus 25, that's 27. Okay, then 27 minus 3, 24. That's how we ended here. So Python will always follow both maths, but to make sure that you're getting exactly what you want, always use brackets. Okay. Alright, so let's look at math operators. It's called math operators or math functions. Okay. So that in case you want to Google and do more research on some of these functions, just like the self-string functions, what you're going to search for is math functions. Okay. So let's look at some interesting math functions. And the very first one is about, we'll look at the seal, and let's start with power. Let's say you want to say 10 to the power of 2. You know how to write it in your code. Alright, one way to write it is to say 10, you put this arrow of 2. So let's start with that. Let's start with that and see what happens. Most people will instinctively write 10 to the power of 2 will give us 100, right? 10 to the power of 2 will give us 100. Save, and then we'll run. And unfortunately, it does not work out that way. So you can't just use this as power. In fact, it's looking at it as minus. If we do it to the power of 6 and we run, okay, you see it's confused. Alright? Now, here is the proper way to write power. You do power. Okay, so you write the number, the first number, comma, the second number. So most programming languages will naturally use this. Okay, so Python is very white space sensitive. It's not like PHP and JavaScript that you can put space anywhere and it will figure it out. In Python, look at, it's telling me missing white space after this, so we're going to do a white space. And then it's okay like this, but I prefer to always do white space like this. Okay, it's complaining about this too. Alright, so here, 10 to the power of 2 will run, gives us 100. You see, so power is a function that you use. Now what if we wanted to do ABS? What is ABS? ABS is absolute value. So absolute value will always give you the positive of any number that you give. Whether the number is a negative or positive, it will always give you the positive. So 10 is already in positive, so ABS 10 will also give us 10. Okay? Now what if it's in negative? ABS negative 10 will give us what? 10. Okay, see? Alright, so the next one is max and min. Okay, max will give you, out of two numbers, it will give you the one that is the highest. Okay, so Out of 10 and 13, which one is higher? So of course, put a space here. Out of 10 and 13, which one is higher? Of course, 13 is higher, so max this number. Max this number is going to give us what? 13. You understand? So another, I think I should be 7 this, right? Another thing we can do is mean. Okay, if there's max anywhere in the world, there's mean. Alright, mean 10, 13 will give us what? 10. Okay, so think about this. What if we had 3 numbers? Alright, let's say we have 3 numbers. You see, it still works. What if we have different numbers? Okay, I'll run mean. Gives us 2. Out of any number of values you pass in here, it's gonna take mean is gonna take it and give you the lowest one. So what if we do maximum and do this, and it gives us 76? You see, it finds the highest number here, which is interesting. So the next one is round. So it will round up any value to the nearest whole number. So let's say 25.2. Okay, so what is round going to give us? If we run it, it's going to give us 25. So if you have a number that has decimals in it and you want to convert it to the nearest whole number, that's how you do it. In a real life scenario, you might be wanting to know how old the person is. If the person is 13.4 years old, you don't want to print 13.4 years old. So you want to know whether they are closer to 13 or more. So let's say we put this at 7. Okay, 25.7. You see that round is 26. Nearest whole number is 26 because of the 7 here. Anything above 5, any decimal above 5 will round to the higher whole number, and the one below will round to the lower. Okay, what if we do cell? Cell for ceiling, alright? And we had 25.2 there, and we do cell. For some reason, why is this not? Am I not spelling it well? This is a little... Okay, cool. I know why. But let's do... before you can use some... It's not all math functions that you can use straight out of the box with Python. You have to import something called basically the Python official math library. Okay, so we have to import it. So you say from this, how to import math. Import everything. Everything is asterisk in programming language. Once you see asterisk, it means everything. Okay, so then we can start using some of these extra math functions. You see, cell means that give us the higher whole number, even if the decimal is lower, right? Below 5, give us the higher whole number. So we go from here. So I think I have to explain this a little better, but more further in the future. This is actually called dependency injection. Okay, basically dependency injection is when your code, the code you're writing, needs information from another file or another library somewhere. You have to import that library at the top, okay, so that you can use it in your code. So why do we have to import math? Because Python doesn't expect you that all your software development, every other project you work on, will need all the math functions. So because of that, Python removed the math function. So you have to only import it when you need it. Okay. In this case, we need it in this operation, so we imported it so that your code won't be that big. Alright. So another math function. Basically, once you import math, everything that is possible on your calculator, or your scientific calculator, you can do it with Python. So here, let's look at floor. Instead of saying seal, let's say floor. So if we say floor, it will still give us 25, right? Floor will give us 25. Well, what if we do 25.99999? It's supposed to, if we say round, it's going to give us 26, but floor will force everything down to 25. Look at this. Okay? So that's the thing with the seal and floor. Like I said, if you go to Google, find math functions, just type Python math functions, and you will see all the math functions in the world that you can use with Python. Alright? Okay. Alright, so let's try something else. Let's see how to accept input from user in the command prompt. So we can say user underscore input dot by. Okay, so first thing we do is if you want to accept if you want the command prompt here to prompt the user to enter an input, you will just start with input, and then you can say what the command prompt will ask the user. So here I'm going to say enter your first name, and we can run it. Oh, we have to switch to this file. Run. We have to select user input file. Okay, good. It says enter your first name. Now I can type here. I can say class first name Wombo, and it does nothing. After typing Wombo, I click the enter button. It does nothing. Okay, so what if we want to also do something with the name, whatever is entered here? So we have to assign a variable to it. So what do we call the variable for our first name? Okay, and now we can do something with the variable. We can do print welcome plus first name. See, this way. And in Python, very space sensitive, and we'll run it again. It said enter your first name. It said Bombo. Okay, that first name says welcome Bombo. Alright, so what if we also want last name? We can do the same thing here and say last underscore name equal to input, and say enter last name. Okay, so here we're going to say welcome first name concatenated with space. Okay, another concatenation with last name, and then we can do question mark, another concatenation with question mark, not question mark but exclamation. Okay, I think we're good here. So let's roll. So we run this. It says enter your first name, say Bombo, enter your last name, say Clark. Okay, so if we hit final enter, it's going to run this code. It says welcome Bombo Clark. Alright, so what you can do is try and enter a title. Okay, so you can say title equal to enter your title. Okay, so just space on, it's spacing every time. So here I say enter your right. Okay, we're supposed to do input, right? Input this way. So here we can then do plus title plus space. Okay, stop. Okay, then we'll do another plus. Alright, so make sure that the spaces are well. Okay, good. Alright, so to first ask title, and then to ask for first name, and then to ask for last name. Okay, so what do we do? Save. So okay, it says enter your title. So now the title is Mr. Enter your first name, you say Mother. Enter your last name, you say Fault. Okay, so hit enter. Hit enter. It says welcome Mr. Mother Faulter. Alright, so that's how to get input from user. So in the next video, let's talk about building a basic calculator with Python that we can enter numbers and it will process the calculation for us. Alright, and this is a common interview question in Python interviews. They just tell you to build a basic calculator, and this will be the answer to that interview. Alright guys, let's try something else. So far we've been accepting strings from users, so let's try and accept numbers. Okay, so here we're going to comment everything out. Control question mark. Okay, so we do. Let's try and do something that adds any two numbers. So it asks for the numbers from the users and then it sums them up. So let's do number 1. That's just a variable, and we say number 1 is equal to input, and then in the input we say enter the first number. Okay, and if you want to duplicate lines in PyCharm, you do Command D or Control D. Okay, duplicate. So we enter the second number. So we print out the sum of the two numbers is. So we're supposed to print the sum of the two numbers here. Okay, so we do sum equal to number 1 plus number 2. Okay, so this is how we do sum. So we can then do plus sum here. Now I want this to show you something interesting. First of all, PyCharm is already giving us a hint. It says shadows built-in name sum. Now, in variable declarations in programming languages in general, there are variables that are already declared by the programming language themselves. Alright, for instance, input was declared inside Python itself and means something else. Okay, and what it means is that once you run this input function, it will ask for input from the user. So you can't just use input as a variable. Alright, some programming languages may allow you to do that, but some will not allow you. You can't use input as a variable. Okay, see, it's getting underlined. So PyCharm will help you know which variables to use and which one not to use. So in this case, sum is a variable that came with Python. We don't want to use sum, so we're going to change it to sum number or sum of numbers. Okay, you see, so now we can use that. So every time you attempt to use a keyword, they are called keywords. Anytime you attempt to use a keyword, the editor will warn you. Alright, let's run this. Alright, then we'll modify it later. There's a little modification we're going to do, but I want you to see something first. So click on run. So it's enter the first number. The first number is 4. Hit enter. Enter the second number. The second number is 6. 4 plus 6 should give you what? 10, right? But let's see what it's going to give us here. It said it gives us 46. Why does it give us 46? Because everything here is a string. The variable type is string, so it gives us, so it sees this as a concatenation, alright, instead of addition. So it's only when these two variables are numbers that it will give us addition. So but if they are strings, it will just join them there. So what it just did, it took 4 and joined it with 6. Alright, it didn't do any calculation there. So for us to force it to do calculation, we must put these two numbers in integer. Okay, so let's say int. Remember how we converted numbers to string by using str in the previous lecture? Okay, here we're just going to type. This thing is called typecasting in programming. Okay, typecasting. Okay, I told you before, typecasting is when you force a variable to become of a certain type that you want, so that your code will not run into errors. Okay. Example is like when you have a form in your, let's say you have a form in your registration page where you ask the user for their name. So their name, they enter a string, right? Like Bumble, right? Then you ask them for their surname, they enter a string. But when you ask for their age, you want them to enter a number. So what happens is that by the time you want to do your calculation, you want to make sure that you force whatever they entered into a number. Alright? Okay, so here we are typecasting whatever the user entered into a number, and let's run again. It says run. Let's enter the first number, we say 4, enter. Second number 6, enter. And it does something interesting here. It gives us an error that says the num2. Okay, I know by now you are already familiar with this particular error, but we're going to resolve it. But I want to show you something first. So look at the error. It says you can only concatenate string, not int, to a string. So when you want to merge two things using a plus sign, make sure that the two of them are strings. So first thing we have to do is to remove the string and see that the result is correct first. So we remove the string, run, first number 4, second number 6, and then we hit enter. It gives us 10. Correct calculation. So what if we wanted to add a sentence to it to make it more presentable? We just do this. So this is what we had before that gave us that error. Let me run it again so that we'll just see the error. 4 plus 6. It gives us this error. It says you can only concatenate. Then from the knowledge of our previous video, we have to convert this answer. So 4 plus 6 already gives us 10. But here we have to also convert it to a string so that we can concatenate it to a string. So here, done that, click run, say first number is 4, second number is 6, hit enter, and it gives us 10 clean, alright, because it's now seeing everything as a string. So this kind of shows you string manipulation. And the last one we're going to do is, what if the user enters decimal, something that has decimal places instead of integer? Integers are whole numbers, was first invented by the Germans during the World War. So what if we had decimals? Okay, so let's run it again and enter decimals. So first number is 4.2, second number is 6.8. 6.8. So the user enters decimal, hit enter, error, because what? Invalid literal for int. So it's expecting integer here to be a whole number. So what do we do when we want to accept a number from a user and we don't know whether they're going to enter a number with a decimal place or not? Okay, so what we do is instead of using integer, we use float. Okay, float is a type of variable in Python. And like I said before, if you can always come here and see under variables, you see the different types of variable on W3 Schools in the Python tutorial. See under variable, there are different types of variables. Okay, output variable, global variables, and variable exercises. So there are some minor exercises. So after doing some of those minor exercises, you kind of get a general idea of the different kinds of variables available. So for now, we have only dealt with 2 or 3. We have dealt with strings, integers, and now we're dealing with floats. Float is anything that has decimal places. So right here, we have converted it to float. We run. First number 4.2, second number 6.8, and hit enter, and it works perfectly well. It gives us 11 complete. Alright, so that's it. As we go further in this tutorial, we'll make this calculator more complex and more powerful to do other types of calculations. So guys, let's build a very small short game. Alright, we're going to call the game Madlibs. So from here, let's create a new file and call it Madlibs. Okay, Alright, basically Madlibs is a game where you ask the user for certain words, and then once they give you the words, you insert it into an already made sentence and see what it looks like. Okay, so let's write 3 sentences. First of all, we're going to write one long sentence that says let's say they goes to school every morning at a place called Ibadan City. Okay, the name of this teacher is Toby. Okay, cool. He is 6 feet tall. Okay, let's say 6. Okay, 6 feet. Okay, so let's say this is a sentence that we want to run the Mad Libs on. Okay, this is the sentence. Now we basically want to ask the user for some names. For instance, the first name. So let's create a variable first. Enter name of person. Okay, that's the first thing we want to the user to enter, and name of institution. So person goes to institution every let's say time of day. Okay, and then the name of his enter occupation is enter person. Okay, name of person too. Name of celebrity. Okay, he is enter number below 10. So number between 5 and 10. Okay, between 4 and 7. All right. Okay, so now we want to collect all this input from the user, and then we insert it into this sentence. All right. Okay. There's one more. It says Ibadan city, so we say name of city. Name of city. Okay, these are the things we want. So we're going to ask for input. Say name of person. We got the input. To say input. Enter name of person. Okay, now I have to duplicate this line. I'll do Ctrl D, Ctrl or Command D. So we do for the second thing, name of institution. Name of institution. Okay, we'll do for the third one, time of day. Ctrl D. Let me just do 3 times time of day. So here I'll copy time of day, and here I will copy occupation, and name of city, and name of celebrity, and then Ctrl D or Command D. Oops, escape. Command D. Okay. So here I will have number between 4 and 7. Alright, so now we have all these variables. We're going to let them go. Delete all. Okay. Good. So now we have this, and we're going to have print. And what are we going to print? We print what we have here. Delete everything and print. Insert question mark. Okay, now we have to start entering the values. So name of person is going to be starting from the beginning. Name of person plus put. Okay, good. And the space. Name of institution is going to be oops. Remove the institution and put plus put. Okay, so here this is how the name of the station could be, and time of day. So we just copy and duplicate. So time of day, every time of day. Okay, every time of day, and we do the same thing for occupation or city name of city. So we'll copy this, and name of city, replace it here, name of city. So I would have to close this somewhere here, so that we can have multiple print statements. So go here. So we can do another print here. Print. Okay, now we have this. Okay, time of day at a place called every time of day at a place called name of city. Okay, so we can close this here too. I'll do print quote. Okay, so the name of the teacher of the profession, right? Space, good. The name of the occupation. Name of the occupation is this, and then finally name of celebrity. We're going to copy this and say name of celebrity is okay. So we have a Madlib. We could also do this one, but I think by now you already get what I'm talking about. So just for the sake of this tutorial, let's just complete this and say how many feet tall is a. It is a number between this and okay. So here we're gonna say enter time of day. Time of day. Enter occupation. And enter name of city. Enter celebrity, name of celebrity, and enter number between 4 and 7. Okay, so now we're done. We run this. Oh, we have to make sure that we're on user input. So we run. Okay, enter the first name we need. So I have to run just to be sure on user input. Run. User input. Step on run. Where am I? User input. Variables. Okay, we're in variables. So run variables. And we're supposed to be in Madlibs. Okay, so we run and run and Madlibs. Okay, so now we are in Madlibs. Remember, you can always drag this down. Enter name of person. We could say Dave. Name of institution, we could say FIFA. Name of enter time of day, we could say afternoon. Enter occupation, we could say footballer, whatever. Or coach, football coach. And then we say enter name of city, we say Abuja. Then enter celebrity name, we say Speedy Darlington. Okay, enter. Number between 4 and 7, say 6, hit enter. And we have a problem there, and that problem is because of the number. Here, we're supposed to do string, str, and that's the problem we had. Okay, so here we're going to rerun, and then we do the same thing again. Field it again, and last number between 5 and 6, and then enter. Alright, let's fix some of the problems. For instance, if you look at the extreme here, it says line too long. Okay, line too long, expecting 126 to 120 characters. Alright, so we're going to break these two somewhere here. We're going to break it and say print. Alright, save. I'll run again. There are some little bugs in our code. For instance, we don't need the plus here. Okay, so it's a problem we had in our code, so I'm just going to fill it again. Run. Now this time it runs after we've entered all this, and then we run. So it says Dave goes to FIFA every afternoon at a place called Abuja. The name of his football coach is Peter Darlington. He is 6 feet tall, you see. So that's basically a very short Mad Libs game. It could be much more complex than this, but this gives you an idea of how to get full user input and be able to construct a sentence with it. So let's look at lists in Python. And to look at lists, if you're coming from something like JavaScript, just know that a list is sort of an array. Okay, if you're coming from another programming language, just know it has to do with arrays. Okay, but let's look at lists. So right click, new file, and call it lists.py. Enter. And then to create a list, you just type the word keyword list, and then you put block brackets, then you list all your lists. So I'm going to list sports, different sporting events, and call them football, skating, 34 or 35. What else? Basketball, like that. Okay, now you can use keyword as a list, but this is a list, so we have to save it as a variable. We'll call it sports. Alright, so now we have different sports. Okay, so let's try and use this list. So we can say print. If it says print sports, what do you expect it to print? Can you imagine? Let's run. Click run, and select lists, and click run. What does it do? It gives us football, skating, 35, and basketball. So the reason I put 35 here is to show you that you can use different kinds of variable types inside a list. So a list is basically a type of variable that you can put other types of variables inside, okay, and store it together. So let's do some manipulation here, some interesting manipulation. The very first one is this list is numbered, just like we saw in string manipulations. They are numbered. So the first number for this list is 0, and then the next number is at location 1 and location 2. So these numbers are locations. Okay, so if you want to pull out anything, it's just like a box, alright, with different demarcations, or a shelf. So if you know the number, the shelf number, and the number of the box in the shelf, then you can go pick out something that is there. So these are like the numbers, alright. So let's say we want to get sports at location 0. What do you expect to get? Let's run it and see what is printed as sports at location 0. It gives us what? Football, because football is the first one, and the array index here is 0. Okay, and the next thing we have to get is like at location 2. Sports at location 2 is going to give us what? 35. You see, even though 35 is a number, when we enter to here, we're able to handle it properly. Now, what if we want to replace something? Okay, let's say, but before that, let's say what of sports at location. Let me put more sports. Running, javelin. Okay, so let's say sports at location -2. What do you think is going to print? Okay, what of when we do put it as negative? it gives us what? Running. Because when you reverse it, it starts counting from location 1, location 2. There is no -0, okay? So 0 will always be this, okay? Then -1, it reverses the array and starts counting from here. You understand? So that's the way to, in Python, to pick up the very last element in an array, you can use a minus. If you know the length of the list, then you can use minus. So in the next video, we are going to look at other functions. Just like we had string functions, there are functions you can attach to array. As you can see, so many functions here you can attach to arrays and or lists and use them to manipulate the list. Okay, but before we do that, the first thing I want us to check is, what if we do something like this? Check out sports at location 1 is what? That's skating, right? Because this is 0, 1. What if we change it to dancing? Okay, and we say print sports at location 1. Or first of all, print sports first. So here we have equated whatever is in 1, we have overwritten it with dancing, right? And here we just run. And what do you get? Football, dancing. You see that skating is gone? Okay, it replaced dancing. Same thing with, if we ever want to use this again at location 1, will always give us what? Dancing, because we changed it above here. So what if we change it below? What happens below here? Okay, we'll print. It gives us what? Skating, because we've not changed it by the time we're printing it, so it gives us skating correctly. So let's look at list functions. So let's look at some list functions. Let's create another list. Grades. Okay. Grades. And what do we have for grades? We have 23, whatever. So these are like the grades of the different athletes. Okay. Alright. In Python, you need to be careful of spaces. So there has to be spaces here. Okay, we're good. Okay, now so let's start looking at the functions. Number one is let's print this. Let's print grades. Run. And it says 23, and note the last number. Let me change this. 80. Okay. Note that the last number is 86, right? So what if we want to extend? We want to merge these two lists. Okay, so we can say sports dot extend, and then we'll print this. So let's say list 3. List 3 equal to this. Okay, so now we can print list 3, right? So list 3 and actually we don't need to append it, we don't need to equate it to anything, so we'll just call sports. So if we have run this function sports.extend grades, and what you're going to see is that it lists all the elements. Each of these things are called elements inside a list. It lists all the elements in a list, and then it also lists all the elements in the second list, which is grades. Now what I want you to know is how many elements that are in this list. The total number of elements in this new list that is printed is the total number of elements in the old list plus the total number of elements in the new list. So if you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's the total number of elements in the new list. Now there is another one called append. Okay, in append, the total number of elements will increase by just 1. So if we have 1, 2, 3, 4, 5, 6. If we append the second list to the first one, it will add the second list here, but then the total number of elements will just be will increase by just extra one. So we run this. What you notice is that you have 1, 2, 3, 4, 5, 6, and then there's a bracket here, okay, that says this new list, everything is inside 1, so it's considered just one element. So during interviews, you'll be asked difference between append and extend. Okay, so just know the difference. Append will merge everything into one and just add it to the old list. So another one we have to check is, of course, many people would think if there's append, there should be prepend. Usually, I'll let you find out. Go on, and you see there is nothing like that. Okay. So let's say you can insert something. You can do list of insert, and then at you mention the location where you want to insert it. So sports at location 0 is football, location 1 is skating. So what if you want to replace something at location 1? Let's say go to location 1, insert diving. Okay. Go to location 1, insert diving, or run the spots. It shows us that at location 1 there's diving. So this is kind of replacing, but this is not replaced because after diving it's continued with skating. Okay, so this is very much different from doing something like this. It's very much different from doing go to location 1 and change to diving. Okay, here I'm going to comment out this so you see. So if we go to location 1 and do this, what we are doing is we are replacing what is in location 1. You see, skating is gone. So inserting and replacing are two different things. So we also have clear. So if we do list.clear, list.clear, clear will wipe out everything. So in case you're working with a list and you get to a point in your code and you want to wipe it out and start it over again, okay. I know we're not building real life applications now, but these are just the basics you need to know for building a real life application with Python. So if we run, we're going to see that if we try to print the sports list, it's now empty. Okay. So another thing is we can remove an element in an array. We can just say remove. So remove. Which element are we removing? We will remove. Let's say basketball. Or let's remove 35. 35, and we're done. And as you can see, 35 is gone. Okay. So another one is pop. Pop will remove. Pop is like remove, but it's going to remove the last one. Okay. It's going to pop. Say dot pop. You don't need to pass any variable, but once you run it, you see that the very last one is gone. Javelin is gone. Okay. So let's look at the border of pop and say jumping. So most programming languages will have pop and push, but here the opposite of pop is to append. Alright, so if we append, you see that jumping is now part of it. Okay, so I just wanted to find that out. Now the next thing we have to look at is index. So if we know a certain element and we want to know its position in the array, we can just say index. Okay, give us the index of running. So if you pass the element, it's going to give you the index. Okay. A good example is when a good example of this is like if you're running a list of, let's say you took a list of registrations and you want to know what position the person is in the register. So that's how you find out your user index. So generally, let me comment this out. If you want to know the position, the index, you just have to pass in the number. Say, give us something at index 2. With respect to index, you have to equate it to something. We'll do like list3 is equal to get us whatever is at index location 2, and we can print list3. Let's come here and print list3 and say okay. And it's saying that there is nothing at index location 2 is not on the list. Okay, what if what if we pass in what an element we know that it's in the list? We are sure that skating is there, and we say give us the location of skating, give us location 1, that is 0, 1. Okay, same thing with if we say give us location of running, and it gives us the number 4, and same thing with 35. We do 35. It can be this, but interestingly, let's run it as a string and see, and boom, there's an error. Okay, some languages like PHP and JavaScript will allow you to switch between variable types, but Python is that's strictly typed, so it gives us at location 2. Now, another thing we can do here is count. Let's say there is a number that appeared here, like we saw in the strings. Like I told you, this string Python treats strings as lists. Okay, so many of the functions you can use in lists, you can use it in strings too. Okay, so here we are going to say repeat some things. We'll say repeat basketball repeated 3 times. Okay, so this contains basketball 3 times. Alright, so we're going to do list of count basketball, how many times basketball appeared, and it shows us 3. Basketball appeared 3 times. Okay, so same thing with sort. So let's try and sort this. Normally we'll sort integers. You will sort integers. So if we say list.sort, and we're not going to equate it to anything, so sports. We're supposed to sort integers, but let's try and sort this mixed variable list and see what happens. So run. You see that there's a problem. Why? Because somewhere it's saying not supported between instances of int and string. So you see, there is a problem. Now let's try and make sure it's just a string, a list. Okay. So it arranges it in alphabetical order. Look at B, F, football, I have J, R, S, you see. So if you want to sort, you have to make sure that they are of all the same type. So what if we sort grades? Think of grades, okay? We say grades.sort. Say grades. And we print. What do you have? It arranges it in hierarchy. Okay, so that's what sort does. What if you want to reverse the order? Here, let me remove some of this basketball. Let's say we want to reverse the order, alright? So we'll do grades.reverse. So we want to reverse, 86 is first and 23 is second. So we'll print grades, and it puts 86 first, and it just basically flips the array. Okay. Now in some programming languages, if you have sort, that means the reverse of sort is assort. But just like the other time, you can't just guess stuff like that in Python. Now, if you want to know what to do with lists, just put a dot, and you will see all the functions. See, sort, pop, count, append, clear, copy, insert. Many of them I did not even talk about. Alright. Now, if you want to reverse the contents of an array, why not Google it? Okay, then you see the function. Alright, finally we're going to do copy. So when you want to copy, you write the first array and then put the second array inside, and sports. So basically it copies whatever is here and puts it here. So let's try and print grades after we've copied sports. The error it gave was that copy does not take any arguments. So what you do let's say we want to copy everything here into everything here. So you can just say sports is equal to sports, you see. So we run, and so if we now print sports, it doesn't give us this any longer. It just gives us this because we've copied this. All right. Now here's the interesting part. If you started to understand programming to an extent, you would ask yourself, why do we have to do .copy when we can just do this? Sports is equal to grades. Okay, we just equate two of them and boom. Guess what it's going to show us? Boom, the same thing. Alright, so in many cases, 99.99% of the cases, you don't really need copy. You can just equate the two variables and then carry on with your algorithm. And now finally, after we've done all these manipulations, let's try and do something called tuples. Let's look at tuples. Okay, a tuple in Python, a tuple is a kind of list that is immutable. Okay, immutable means that it cannot be changed. So usually when you're writing your code, very rarely, but there are some instances that you wouldn't want your code to be changed at all. Alright, something you passed into a list, you wouldn't want it to be changed. Okay, or edited, modified. For instance, when you're building blockchains and you want to save the user's address, okay, Ethereum address or something, you don't ever want it to be changed. Maybe you want to save the Ethereum address and some other private key, public and private key pair. You don't want it to be changed. So in this case, a tuple is just a list. So let's create a tuple and say fruits. Okay. The way you differentiate tuples from lists is that you're going to use a round bracket. A list uses what? A block bracket. So you don't put fruits. So fruit is let's say a fruit is mango, orange, pear, and these are fruits. Okay, so let's try. I told you that tuples are immutable, you can't change it. So let's try and print the fruits first. Try and print fruits and say run. I print the fruits. Fine. Let's try and change fruit at location 1. Okay, so fruit at location. Okay, before we change that, let's print it. Fruit at location 1 is equal to this. Gives us orange. Okay, so let's try and change it the way we would normally change lists. Okay, if we want to change list, we can say list at location this should be equal to, we can say cabbage. Cabbage. I've forgotten the spelling of cabbage, or I better change it to something like that. Cabbage. Okay. So fruit at location 1 is cabbage, and you see the editor is already coloring it. I can't even change this color as a way to warn me that you can't do that. So tuples don't support item assignment. It's already telling me you can't change what's inside. So if I run this, I'm going to hit a roadblock. Okay, tuple object does not support item assignment, so I can't change it. So if I'm writing a code, I know that every time I call fruits, I will always get this. No part of the code would have modified it. Now the idea is that in a real life scenario, let me change this because of this place. In a real life scenario, a single page could contain 10,000 lines of code. All right, and you are trying to check for hundreds of different things inside your code, and occasionally a certain item you're working with might have changed, such as in a transaction platform. If you're building a financial platform, a certain item might have changed. And if it changes, it will change the entire result, and then real money will be lost by the user or gained by the user. So you want to make sure that some key things you don't ever want to change will be in tuples. Now, another real life example is location. When we are working with geolocation, there are certain arrays or variables that have to be together all the time and must never change. A good example is coordinates. Okay, coordinates. So a coordinate will contain longitude and latitude. So in real life, it's going to be something like they will say, like Google Map will say, your location is your location is, it will do whatever number, comma, whatever number. That's longitude and latitude, your location on the globe. So if you are working with geolocation, you want to make sure that you save that in a tuple, okay, so that it never changes. They must always be together and they must never change. So but 99.99% of the times you're writing a code, you're working in Python, you're using lists. Tuples rarely ever come by, but I just put this to let you know what it is. Alright guys, let's look at functions in Python. So to start with, we have to create a file and call it functions. So to avoid using a keyword, I'll call it functions functions 2.5. Remember what I told you about keywords. Generally, when you're coding, you avoid words that are likely to have been used by the programming language originally. So here, what is a function? A function is basically like a box, okay, where you put some code, you write some code that does something, and you put it inside a function so that you can reuse that code every other place, alright? So when you want to define a function in Python, you start with the keyword def, okay? Def defines the function, then you give the function any name, just like you would name any variable, but you avoid keywords, right? So this function, let's say add numbers, okay? This function is going to add numbers for us, and then this is how you define a function. You put a colon, then you hit enter. So that's how to define a function. Now the reason it's underlined here is because I've not used it. Function name should be lowercase, okay? So usually you do underscore n. Alright, so in JavaScript, this is how you would have defined this function, add numbers. This is how you would have done that in JavaScript or PHP and many other programming languages. But Python is non-curly braces, okay? So you're never going to use curly braces. So instead, it uses indentation to know when we are working within a function and outside. So if I do Dave, whatever here, this is inside this function because this line shows that it's inside the function. But if I hit enter and keep backspace and write here, it means that this one is outside this function. So what if I have another function? Sometimes you can have a function inside a function. So this will be a function inside a function. Same way, same indentation, right? To tell which one is which. Alright, now so let's do a function that adds before we do the one that adds two numbers, let's do the one that just says hello, okay? So we say underscore hello, alright? So we'll print. Before we even print, let's do message. Okay, you can see our message is hello there. Okay, so let's run this function. We'll click run. First of all, we have to select the file, run, select the file, function tools, and then run. You will notice that you will not see anything. Nothing happened. There were 0 things on our command line, and the reason is because we've not told Python what to do with this thing. So this is something that is run inside the function, but we've not told Python to spit it out. Okay, so we tell Python print our message. Okay, so this is when Python will do something. So if we write, we'll run, and you notice that Python still doesn't print it because defining a function is one thing, alright, and then using that function is another thing. So we're not using it yet. We're still defining what will happen whenever somebody calls the function. So to use a function in Python, we use the word call, okay, like a phone call. Okay, alright, so let's call this function. We've defined it, and we hit the backspace to make sure that we're outside the function, and then we can say hello. That's exactly how to call a function in Python. So it says expect 2 blank lines after class or function definition. So here we just have 1 blank line, hit enter, and this is 2. And you see it works well now. And if we now call it, it's going to print hello there. Okay. So what if we remove this line? Let's comment it out. What happens if we print it? It says nothing. Even though we're calling the function, we didn't tell it to do anything. We just said assign this value to this, and we didn't tell it to spit out anything. Okay, now that takes us to the second part of this, where we look at something called return statements. So sometimes you don't want a function to print something to the screen, but you want it to return a certain value so that you can use that value in another function. Okay, so here, let's say here we define a variable and call that variable 3. Okay, and then we define another variable that 2 and call that variable 5, and then we say print var1 times. This is times. The asterisk is times in programming, var 2. Okay, so what do we expect here? I can comment out this. Okay, let's just comment out everything. Command and question mark comments out everything, and I run. So what happens is that it does 3 times 5, 3 times 5. Okay, so let's say we are also running something else. Highlight everything, command, and we want to print. Let's say we can do print. Let's say inside here we do 3, we do 5 plus 2, var 3 equal to 5 plus 2. Okay, then we can do this. Make sure that you have the necessary indentation. Okay, if you don't have the right indentation, Python will always warn you. Alright, so we have battery, and we define it as 5.2, 5 plus 2. So let's say we comment this out, okay, and we say print, say hello. Alright, first thing you notice is that it prints nothing because inside the function we didn't tell it to print anything. But what if we do return var2? Okay, now the function knows what to return. It does this calculation, assigns it to this value, and spits it out. It will spit out what 5 plus 2, 7. Then whenever we call this function, what we're going to get is 7. So if we print here, print, it gives us 7. Alright, now this 7, we can use it for calculations. For instance, we could say 5 times say hello. See 35. So 5 times this function goes here and does all the calculation and tries to print it out. Another thing we can do is what if we put it above? Okay, so let's say we put it above. What do you notice? It colors it immediately because we are trying to use a function we have not even declared. So it's an unresolved reference. So if we hit run, it's not going to work. So I know that in some programming languages you could use a function anywhere while you call it anywhere. Okay, but here you have to have called it before. You have to have used it. Okay, you have to have defined it before you can call it. All right. So you can use two functions side by side, assuming there's another function that does something else. You can use them as long as they are returning integers. Okay, you can use them as calculations. Same thing we have here. The way we have var1, we can also do something like this here for calculation. So let's hide this point. You see? So for calculation, we can do run. So it does the calculation, multiplies everything out. Okay, so another thing we can do is parameters. Let's look at parameters and functions. In functions, there are parameters. Parameters are values you can enter whenever calling that function, such that the function will use those values and do its calculation. So first things first, let's say here print hello world. Okay, so if we run this function, what's it going to show us? Nothing, of course, because we've not called it. So if we call it, we say hello, and boom, it shows us hello world. Now what if we don't want it to say hello world, we want it to say the name of the user? We can say pass username. We can pass a variable there and say, instead of hello world, we say hello plus username, and we save, we run. It tells us nothing. It throws an error because whenever you declare a variable, a parameter like this, whenever you're calling the function, you must enter that parameter. So here, we have to enter a parameter and say Dave. Sorry. When calling it, this function expects at least one parameter, string. I have to enter it. So once we pass Dave into this place, what this function is going to do is that it will come back here and replace this username with Dave. Okay, so let's call it. It says hello Dave. We can put multiple parameters. For instance, we can put age. Here we can say hello Dave. You are 8 years old. Okay. So we could say hello Dave. We put 22 here, and then we run. It says there is a problem. Of course, the usual problem we face, which is you have to convert it to a string. You have to typecast it. So we'll typecast it. Since the whole print is a string, we have to typecast it and then take note of spaces. And then another space. We'll go, we'll run, and boom, it says hello Dave, you're 22 years old. Okay, so that's exactly what a function is. There are many use cases for functions that we'll see in the near future, but this is just what it is. The most important thing to know about return statements is that once you put your return, once you type return, the function ends there. It stops processing beyond that point. It cannot work. If you had another story, let's say we have something like this. If there's a return here, this will never be processed. This function will never get here. So once a function says return, it terminates there and outputs whatever you put in front of it. And you don't always have to put a value in front of return. If you just write only return, the function will terminate exactly there. So if I run this, you see that this never gets printed, the return post there. So what if I say return to 1? You see? It never gets to this point. Never. And the return to is not being printed, so unless we do print. Let's do a print. And run. You see, it shows us 2. The rest of this line is gone. Alright? Another interesting thing is, what if we put this return here? Okay, so this rest of this line runs, but let's see what the return statement will do. Here, we'll run. It says, hello Dave, your age, you are 22 years old, and it returns 2. So, return is one of the primary things to note about functions, that sometimes you're writing a code and you want to, once you get to a certain point, if something happens, that code should terminate there and not check for other things. Alright? You use return statement to tell the programming language or the compiler to stop there and move on to the next piece of code. Alright guys, let's look at if statements, okay? Control structures. What do I do here? First of all, close this off and create a new file. Right click here, new file, then call it if statements or control structures. Control structures. Okay, so if statement in programming languages, especially Python, provides you a way for you to check whether conditionally do something. Alright, they are conditional statements. So it helps you to check whether something happened before running a certain piece of code, so that so far all the code we've been running has been running. Alright, the first what do you call it, conditional statement we saw was return, like if we did return somewhere. But also return is not exactly a conditional statement. Okay, so here we're going to see conditional statements. So the first thing we're going to say, let's set a variable and then do something only if that variable is something else. Okay, so let's say create a variable, call it fruit price. Okay, fruit name equal to mango, and then fruit name 2. Okay, let's say fruit name 1 equal to cashew. Okay, so let's say price fruit price equal to 50. This 50 could be 50 USD or whatever, $50 like this, whatever. Okay, so here let's print, first of all, let's print fruit price. Okay, fruit 1, let's say fruit price fruit, okay, is cheaper. Okay, so in printing this now, it's easy. You just have to just run it here. Alright, so you just run it here, and it says make sure you select the file and say debug and control structures. I think I should change these control structures to conditional statements. It says fruit mango is cheaper. Okay, now what if we want to check the price before we decide which one to print? Okay, so let's say fruit 1 price, fruit 1 price equal to 50, and fruit 2 price equal to 70. So we can now do an if statement. Okay, in Python it's just as simple as writing if. Okay, so you say if, then you write the condition you want. So in this case we're just going to say if fruit 1 price is greater than 30. So we're going to print this. In Python, remember Python is white space sensitive. Okay, so you put a colon at the end of it. So that's how it goes. So what do you think is going to happen here? Fruit 1, we're saying if the price here, this is fruit 1, is greater than 30, print fruit 1 is let's say more expensive. So what do you think is going to happen when we run this code? Will it print or not? We run, and boom, it says fruit mango is more expensive. Why? Because in reality this price is greater, which is 50, is greater than 30. Okay, what will happen if we reverse the signs? Okay, so these things are called operators. This greater than sign, less than sign, whatever sign you put in between two variables is an operator. So this operator now, if we say if fruit 1 price is less than, okay, let's say cheaper, and when we run this, of course it's not less than, so nothing gets printed. Okay, so what happens is that the code inside an if statement runs only if whatever conditions you present here return true. Okay, if it returns false, that means it's not going to run. So here, foot1 is not less than 30, which means it's false. If we say if foot1 is less than 30, foot1 is not less than 30, so it's returning false, that means this code will never run. Okay, so let's try something else. A good example. Person 1 equal to male. Oops, sorry. Person 1 equal to male, and person 2 equal to female. Person 1 height equal to 6 feet. Person 2 underscore height equal to 5 feet. Okay. So good. Now we can run an if statement. So to run an if statement, there is also, let's say, if person 1 equal to male, print, we can say person 1 is person 1. Okay. So this way, what do you think is going to happen? We are checking if now this double sign. Let's run it first. Run it. Person 1 is male. Okay, because of course person 1 is male. Now what you have to know in Python and generally in programming language is that double equal sign means equivalent to. Alright, we are checking if whatever is in person 1 is also equivalent to this. It's different from single equal sign. Now this single equal sign is called an assignment operator. This assignment operator simply overwrites what is here with what is here. You understand? So if I did print here, let me zoom out a little. Print person 1. What it's going to print is male. Okay, so let's do this. Comment this out. Let's print, and what you're going to see is male, right? Now, what if we, after defining person 1 here, what if we come here and define person 1 again, equal to whatever? What do you think is going to happen when we try to print person 1? If we click run, it prints whatever and ignores what is here. Initially, we assigned male into this variable, but now we are assigning again whatever to overwrite what was there. So single equal sign is an assignment operator to overwrite what's inside, but double equal sign can only be used inside an if statement. So every time you write your code, which is a common mistake new programmers make, they accidentally use double equal sign outside of an if statement. There is no other place in programming where you use double equal sign. It has to be inside an if statement or ternary operator, binary and ternary operator. Okay. So here, double equal sign, there is triple equal sign. Okay, in some languages. All right. So when it's triple equal sign in languages like JavaScript, PHP, it means that it's checking whether the type is the same. Because such languages, for instance, can have person 2 height equal to 5. You see? Like in PHP does not really distinguish between this and that. You know, this is an integer and this is a string because of the quotes, right? Now, in some languages, there's no distinction, alright? But in Python distinguishes between two of them. Okay? So in case you're ever writing any code anywhere else and you see equal sign, it means that it's not just checking whether they're equal, it's checking whether they are of the same type, more or less. Okay, so our code basically uses double equal sign. So you can never use a single equal sign inside an if statement. Okay? Almost never, let me put it that way. You can almost never have a case where you are using a single equal sign inside an if statement. So if you ever write a code that is not working well and you see a single equal sign here inside an if statement, you have made a mistake. As you can see, my editor is already warning me. You can't, because if you do this in some languages, this will always overwrite this, and this if statement will always return true. So that's a question they normally ask in an interview. If there's one equal sign here, what happens? Basically, you're saying, if there's one equal sign, what you're saying here is, if person 1 is successfully assigned to, if male is successfully assigned to person 1, run this. That's what this means. But if you put double equal sign, it's saying that if whatever is in person 1 is also equal to male, then run this. So what if it's not equal to male? How do you write it? So we're going to do elif. Okay? Elif is also the same as else if. Okay? Make sure that your spaces align there. Okay, so here we're going to say else if. So you do the same kind of thing. Else if person 1. Here we use the not operator. Let's say for now, let's say equal to female. Run that colon. So print duplicate. Okay. So you see, we're saying if person 1 is male, print this. If person 1 is female, print that. Okay, so if we run, it says, okay, I have to delete this. No longer need it. So here person 1 is male, so only this one printed because this one went through. So in an if, this is a chain, right? A chain of if and elif. You can do endless elif, but the first one must always be if. Okay? What if we do elif person 1 equal to Dracula? Okay? Print. Person 1 is a dragon. Cool. So if you have a chain of if, elif, what's going to happen is that once one of them comes through, it breaks out of the whole chain. Alright? So if the parser, it's called parser, okay? Parser is basically how or whatever in the computer that reads your code, and it reads it like it's reading English language. Okay? From left to right and down, left to right and down. That's what how the parser reads it. As it's reading it, it's interpreting the code you wrote and deciding what to run. Now, if the parser is running through this and this one comes through, it skips the rest of this. No matter how beautiful the code you wrote there is, it's not going to run it because it knows that at least one of these conditions is true. So what if the first one fails and the second one is true? It skips the third one too, alright, and ignores the failed one. So let's say here we wrote something different, and here we said male. Okay. If person 1 is male, okay, let's do this. Okay, that's the first elif, and here and here, okay. So we're trying to know which one is working. I don't know what happened to my voice this whole day. Okay, so here, if we run, it says person 1 is male, first elif working. So you see, first elif working. So this code conveniently skipped this because this never came through. Person 1 is not male, so. Okay? Person 1 is male, it matches, right? And this third one never ran at all because the parser has seen the one that turns true. So what if all the conditions failed? What you do in programming, you do what the last one should be an else statement that says, okay, what if everything else failed? Alright, everything fails. Let's say the person 1 is not male, so. Okay, let's say person 1 is not a giraffe. I'm not a lion, I'm not a Dracula. Okay, so what do? So if everything fails, there is a condition that you can put that will make sure that if everything fails, that particular code in that condition will run. So you can say it's used as else. All right, usually the last block in an if else chain. All right, we print person 1 is none of the above. Okay, so make sure the space here, no white space. Okay, run. You see, person 1 is not a giraffe, not a lion, not a Dracula, and the last one run says person 1 is none of the above. So what happens if we remove the last one? I've removed it and run. Nothing happens, right? All of them failed and nothing happened. So sometimes in your code, you could get to a point where if everything fails, they should print something. All right, like a student is not has not paid their school fees and not done their registration and not attended the first lectures in your education management app, then you tell them to do something. All right, so that's how if works. Now we can use that in a function. So let's write a function. Who remembers how to write a function? Let's say there's a function. This is how you define a function. The print welcome. Okay, let's call this function welcome message. Okay, put a quote like this, and then okay. So let's write a code that will run into this function. We can say print welcome Mr. plus person. Okay, so let's delete this. So we're running a function that will print if whatever is passed into that function, remember parameters, is changed. So let's say this will accept a person parameter. Okay, and then our gender, person, 2 parameters, and then let's call this function. To call this function will be welcome message. So we have to pass in the 2 parameters. The first one is male, and the second parameter is person. Let's say the person is Dave. Okay. Now this is getting on the line because every time you declare a function or class, you must put 2 blank lines. Okay, that's how Python works. So we run. It says welcome Mr. Dave. All right, but then you see that we did not do anything with this male. We put a gender, but we did not do anything with it. That's why it's colored differently. Okay, so but what if we decide to print a different message if it's a woman? Okay, we can do if. Okay, if what? We can say if gender equal to male. We'll move this here. Print this, and then we'll do elif. Gender equal to female. Print that. Okay. Print welcome madam or miss. Okay. Welcome miss. Okay. Person. Always remember the column. So why is this happening? Okay. Learning about the space, it's saying indentation is not a multiple of 4, so to solve that, make sure you bring this to the top and hit enter so that Python will indent it properly. Okay, so if we run, so what happens, it says while we're running it, okay, well, this is calling, this is where you call the function, this is where you define the function. So while we're calling it, we put male, and inside that function we said if gender is equal to male, print this one. Otherwise, print that. So let's do the final else. Else colon. What do we do? Print gender is cisgender. Okay. Okay, let's do it this way. Person, it's his gender. So there are so many genders in the world these days, and or queer or whatever. Okay. So let's run. So it says it's male. So we're calling it here. Here we're calling it. It says we're passing in male as the gender, and what you see is that inside the function, only the first one runs. Okay. What if we change what we are calling and say female? Female will run. You see, this only the second one runs. It said print welcome Miss Dave. See, only the second one. And then what if whatever we entered is not any of the gender, and we run? It says Dave is cisgender. You see, the last one is what runs. So that's basically each statement for you. It's so easy, and once you figure it out, you can use it anywhere, both outside and inside of a function. And we're going to use it somewhere inside a loop once we get to control structures. So let's look at another operator. Another operator is not equal to. The way we have double sign as equal to, not equal to is exclamation and equal to. Alright, we have seen greater than, we've seen greater than, we've seen less than. So let's look at not equal to. Okay, so what do you think this code will run? Alright, and here we're calling it, we're passing in lion. So what's going to happen is that we passed in lion, and the gender is not equal to male. So lion is not equal to male. So what's going to happen is that this first one will run, right? And then it will ignore the rest. Even if I put female, okay, so let's run it first. You see the first one run. What if I put female here? You know, this else statement is supposed to run if the gender is female, but we have already said that if the first one is male, okay? So let's say the first one ran and ignore the second one, okay? Another thing we can do is there's an OR operator, okay? So if we say if the first one is male, or gender is female, run Mr. X. So or in an or statement, at least one side must return true. Okay, so we're saying if this returns true or this returns true, then run this. So what do you think is going to happen? Even though female is here, if we pass female, the first if is what's going to happen, run. So if we run this, it's going to say welcome Mr. or Mrs. Dave, because at least one of them became true, and that is the second one. Okay, so that is how to write or, and you can chain multiple or endless or and so on. Another thing I want you to check is AND. Okay, so if we use AND operator, the first one is going to fail because the gender is not male and female. You see, gender is not male and female. Okay, that's why the second one ran. As you can see, the first one failed. Now, so where do you use this kind of AND operator? In mathematics. Okay, so let's say we do height. Okay, and here we enter a number instead of gender. Do height. Okay, so let me delete all this so that I don't confuse you. So we're entering person's name, call it person name, and entering height. Okay, then we print. So we can say if this person, if height, okay, is greater than 5, or is greater than 6, and height is less than 7, okay, colon. Now we can print. So now we can print. We'll refactor this and make it a better code. So now we can print, let's say, you are actually tall. Okay. Then we'll do elif. elif height is greater than 7. Okay, you can say print you are too tall. Okay, colon. I will say finally else colon print you are too short to participate in the army. Okay, most country armies will have a minimum height of 5.3. Okay, most countries will have minimum of 5.3. So why do you think this is getting underlined? There's a shorter way to write this, very shorter. So let's run this first. And why is it not printing? Because we've not called the function, we just defined it. So let's call it. We'll say make sure there are 2 spaces. 1, 2. Okay. We'll say print. We'll say welcome message. So we pass in height. Height is 6 feet, and name is Dave Partner. Okay, that's my name, Dave Partner, and we'll run it. It says you are too short to participate in the army. Why is it saying you are too short? Because this does not run, and this failed too. Why did this fail? It says if it's greater than 6. So 6 is not greater than 6. I entered 6. 6 is not greater than 6. Alright? If I had put something else like 6.1. You see, 6.1 is greater than 6. So these 2 conditions, when you use an AND statement, the 2 conditions must fulfill, otherwise it will break. Okay? So 6.1 is greater than 6 and less than 7. Okay? Here, let's try putting 8 here. Let's put 7 first. Okay? Let's put 7. Run. You are too short to participate in the army. Why did this one run instead of this or this? So let's look at it again. 7 is greater than 6, right? So this one returns true. And 7 is not less than 7. So it failed. In an AND statement like this, 2 of them must return true. If it is OR, then at least one of them will return true. If we had used OR here, let's use OR and run. You see, you are actually tall. You see, one of them returns true because 7 is greater than 6. So we are looking at AND operator. So what do we do to include 7 in the bracket or in the loop or range? You can do greater than or equal to. This is less than. Less than is your left hand. If it turns like this, it's less than. If it turns the other way, it's greater than. So here, 7 is not less than 7, but it is equal. So this first one is going to run. Let's run it. See, it says you actually tall, so it's run. Another thing we can do is that time we had issues with 6. If we enter 6 here, 6 is going to fail because 6 is not greater than 6. Let's run it. You see, it failed and this one ran. Okay. Now, but what if we put greater than or equal? So it means it includes 6. So if we run it now, see the first one is what ran. So that's programming for you. You can always check whether something is greater than or equal. Now these operators can only be checked can only be used when you are working with integers or floats like numbers. Alright, if we had a string here, it wouldn't work because it won't be able to compare them. Alright, so what if we enter the string here? Let's say giraffe. What do you think is going to happen? Instead of entering a number, we'll enter the string. Say error, you see? Because these operators, just like in maths, you can only use them on numbers and not on strings, okay? So that's, you've seen a greater than, less than, greater than or equal to, less than or equal to. You've seen, what else? And, you've seen or, statements inside each statement. So these are comparison operators. They are called comparison. So use it comparison. So use it to compare two sides of the equation, and the programming language will tell you whether it came true or false. Now this is basically a programming language way of doing the truth table. Who remembers truth table? So if you did it in school, truth table where we have true, false, and so on. You understand? So this is basically the truth table. If you did electrical electronics engineering, this is basically the AND gate or OR gate. Alright? Those are gates. And actually at the basic level of it, that's what's actually happening on the computer hardware. It's AND and ORs that are running. Okay? Alright, so let's move on. So let's run and make sure everything is working well. Now, I told you there's a shorter way to write this. Okay, so if I place my mouse here and say simplified chain comparison, you see that Python has this shorter way of writing it. Okay, it says if height is between 6 and 7. See, that's a shorter way of writing it, as opposed to this. We're saying if height is greater than or equal to 6 and height is less than or equal to 7. Python says, hey, look, you can actually write this way. You understand? So if you prefer any of them, that's how to write them. Now let's look at let's write a short program. Here's an assignment. All right, pause this video and try to do it on your own, and then you watch me do it in the next video. A short program that takes each user input, okay, two numbers from the user, and calculates them based on the operator that they put. So that's a very mini calculator, a little advancement into the other calculator we built. Okay, so this user prompts this calculator on the command line will prompt the user to enter the first number. They will enter it. It will prompt them to enter an operator. They will enter it, and then it will prompt them to enter the second number. They enter that, and then click submit or hit enter, and then the calculator computes the two values based on the operator, and then give them an answer. So mini calculator that does just three computations, which is plus, minus, division, and multiplication. Okay. Alright, so pause this video and do that, and then you can restart and watch me do it here. Alright, hope you've done it. Did it work? Watch me do it here. So we are going to take user input. So user input, we're going to say num1. I'm just declaring a variable and say float. Not float now, but let's say input first. Enter the first number. Okay. Alright, num2. Input. Enter the second number. Okay. Number 4. Good. Now let's look at then we'll say operator. Operator. How do we call it? The operator. I don't want to use a keyword, alright? So that's what I was thinking of what to do. Now I can say input. Enter the operator. Okay. Now what you have to know is that Python, the parser will run this in order. So we want the operator to be in the middle. Okay, so you enter num1, then it asks you for operator, you enter operator, and then it asks you for num2. Okay. Now the next thing we're going to do is to use an if statement. Now I hope you remember that since we're expecting numbers here and decimal numbers with possible decimal places, we're going to do something like this. We're going to say num1 equal to float num1. So we're taking this num1 and wrapping it around the float. Whatever the user enters, we convert it to a float, okay? Or cast it to a float, and then reassign it to a new variable, or maybe the same old variable, it doesn't matter. But instead of doing this again, you know, I could do this. Do the same thing for num2. But this is two variables. Why not we do it here and say float? Anything the user enters here, to avoid we seeing errors, okay? We'll convert it to a float. Okay. Good. The next thing we're going to do is you use if statements we use if statements to check. So if num1 is, we're looking for the operator, okay? If the operator is equal to a plus sign, then do num1 plus num2, okay? And we do elif. The operator is equal to minus sign. So what do? So I want to copy this and reproduce. Num1 minus num2. Okay, so I want it to be printed. Print num1 minus num2. So we'll see it on the screen. Print num1 minus num2. Okay, so always put your colon. Always. Okay, then we'll do another elif. The operator equal to division. Print num1 divided by num2. Okay, always put the operator. And finally, we do elif. The operator is equal to multiplication sign. Okay, colon, we do print num1 multiplied by num2. Okay, so that's a very basic calculator, but we have to put the final one, otherwise, which is else, put colon, we say print we say the operator is not an operator, okay? Not an allowed operator. So whatever the person entered, we're going to say that thing is not an allowed operator. So if you look here, you see that we have a very neat code. So the user enters details and everything, and then we check based on what the user entered. We try and do some calculations. So let's run and see. It says enter the first number. I'll say 4. Enter. Enter the operator. I'll say plus. So enter the second number, 2. Hit enter, it gives me 6.0. So why is it put it in 0.0? Because we wrapped it around float. Okay. So because we wrapped it around float, we can run it again and use numbers. Let's say 47 divided by 23. Hit enter. So as you can see, it's comfortably giving us decimals. Alright, so that's a basic calculator for you. Now you understand how to use if statements. One thing you can do is to try and put this if statement in a function, and instead of you just call the function. Alright, instead of printing to the screen, you just call the function with the parameters. Once you pass the 2 parameters plus the operator, the function runs this if statement, okay, instead of you printing through the command line. So that's one thing you can do, just to be sure you understand the program so far. Alright guys, let's look at dictionaries in Python. Okay, so basically a dictionary is the equivalent of JSON in Python. Okay, it just looks almost exactly like JSON, and functions similarly. Okay, dictionary. So if you don't know what JSON is, it's fine. Basically, where two applications want to talk to each other, the data that this application will present, or the interface that the application A will present to application B, will be in JSON format. Okay, so basically, let's say you created a platform that has thousands of users, your website that has thousands of users, and then you have a mobile app that wants to be fetching information from that website. Now remember that website will be accessing your database, but the mobile app shouldn't have access to your database, but it can have access to the website. So the website will be feeding information to that mobile app, and that information to be feeding to it will be in JSON format. That's what JSON is, okay? So we're going to write dictionaries here, and just know that if you have seen dictionaries, it's just the same structure as JSON. So a dictionary also looks like an array in a way and behaves in a way like an array, okay, but with one or two specific rules. So let's create a dictionary of months. So let's say months of the year. Okay, so this is how you create a dictionary with this. Now we can start writing. Let's say I want to create a dictionary that has only few short words for a month. So if I entered Jan, it will give me January. You know, like sometimes in some apps you use short words or long ones. So a dictionary works with key value pair. Okay, then comma, then you do that 12 times. Okay, January, Feb, March, March. So I'm gonna pause this video and do the rest and then restart to show you. Alright, so this is our own month of the year. Alright, and it contains short forms for each month. So if we make a reference to a short form, it should give us the month. So if we do print months of the year at location Ma. Okay, to print this, I'll print. What is it going to give us? Oops, I have to run this particular file and then gives us March. Okay, so we're able to see month of the year at location Ma. Now, first important rule about dictionaries is that you can't duplicate items in a dictionary. Okay, so that's one reason why it's used over arrays in some cases. Okay, if you have a set of values, these are called key value pairs. So on the left is a key and here is a value. Alright, so if you have a set of key value pairs that must not duplicate, that's when you use that's when you use dictionaries. So let's say we'll duplicate here, Ctrl D. If you want to duplicate any line in PyCharm, just Command D or Ctrl D. It's duplicated, fine. Everything seems to work well. We run. So it's a rule that you must not duplicate things in dictionaries, okay, in Python. Now there's another way to access the dictionary. If we say here .get, okay, we do .get, it does the same thing. So if we do null here, run, does the same thing, okay. And one more thing is that it mustn't be strings here. You can do numbers too. 5. Okay, let's say 1, month 0, month 1, month 2, like that. Okay, and so on. So you mustn't use names here. So if we run and say give us something at location 2, gives us March, right? Because March is at location 2. Now also, what if there is nothing at location 2? You want to select a number, but you also want to give a default message. You can also say nothing at this location. Let's say you say give us something at location 22 and we run. So it's nothing at this location. Okay. What if you say give us something at this and it says December? What if you say give us something at Dracula and gives us nothing at this location? Okay, so that's how to use dictionaries. Okay, rule number 1: don't duplicate items. You can't have duplicate items in a dictionary. Okay, not items, but more importantly, duplicate keys. Okay, you can't have duplicate keys in a dictionary. It's not allowed. And make sure that there are 2 ways to get information from a dictionary. Okay, so guys, let's enter into this chapter where we talk about loops. Alright, in programming languages, a loop, it helps you to run a certain piece of code over and over again until a certain condition is met. Okay, there are different kinds of loops in Python, and now we're going to look at the first one. So I'll name this file while loop. Okay, that's the easiest and the best. Okay, let me not say the best because each of the loops are used for different things. So I'm going to call this loop while, so that the pi, okay, so that all the loops. What did I just write? I don't have loop while dot pi. So refactor, rename, and we'll change it to pi, okay. Refactor. So loop while dot pi. So I click on that, and there we are. Okay, I think I have to close all these other many different pages that we had here. Alright, don't forget to subscribe and follow me on YouTube. In case you don't know, I'm on YouTube as Brain10org, okay? Or youtube.com/Brain10org, youtube.com/c/Brain10org. Or just go to YouTube and search for Brain10 or Tutorial TV. I'm on Instagram as Real Dave Partner. Okay, that's me on Instagram at Real Dave Partner. Alright, and you can email me at realdavepartner@gmail.com. That's me on email. You want to talk one-on-one? Alright. Okay, so let's look at it. Let's print numbers 1 to 10. Okay, so I'm going to say print 1. Let's run this file. Oops. Click run and loop while and open. So it prints 1. So what if we want to print 1 to 10? In reality, you would do something like this. Control D. So it will print 1, 2, 3, 4, 5, 6. As you can see, man, I'm already tired. 7, 8, 9, 10. So there's a problem with this, alright? The whole idea of programming languages is that you should be able to do things and hand it over to the computer, and the computer will do that so many times, alright, and do it in your absence, okay, without your input. So generally, as a rule of thumb in programming languages, if you're ever going to do something and you find yourself doing the same thing the third time, you've done it the first time and you write the same piece of code somewhere in your application again, by the time you're looking at it the third time, you should write a function, okay, put it somewhere so that you can just make reference to it. You can just call the function, passing in parameters, and that concept in programming languages is called dry, okay. Don't repeat yourself. In fact, many people will tell you that if you're going to do the same thing twice, you better write it once in a function and call it. So what you can see is that we did the same thing many times. The only thing we were changing was just the number. We were incrementing the number. It's called increment. Okay, we were incrementing the number one after the other, and this is not the programmer's way of doing things. This is not the way of the programmer. Okay, programmate. Okay, it doesn't exist. I just made up the word like karate, the way of kara. Okay, now how do we do this in programming? We can write a function. We can write a piece of code that loops over until it gets to 10, then it stops. So one way we can do that is while loop. Okay, so in Python you just write while, and then you write the condition. Okay, so let's start with a condition. Let's say x is equal to 0. Okay, that's a condition. You can say while x is less than 11. Okay, let me start with 9. Okay, remember we want to print numbers 1 to 10. We want to write a piece of code that will print numbers 1 to 10. Okay, or let's do 10 first. Okay, I know why I'm doing that. Put a colon and hit enter, and now we can write what should happen. What should happen? Print the value of x. Okay, and then print x. Okay, so if we run this function now, it's going to enter into something called an endless loop. Why? Because what this while statement does is that it comes here and writes x. It checks. This is a check, just like that if statement. It checks is x less than 10 yes, 0 is less than 10, and it prints 0. Okay, it comes back again and checks, is x still less than 10? If yes, print this. So in this case, no matter how many times it comes back, 0 will be less than 10. So it will keep printing 0, 0, 0, 0 forever, and until it crashes your system. And in fact, some browsers will crash, and these days some editors will warn you. Okay, so out of curiosity, let's run this 0, 0 endlessly. So let's change this code. As you can see, as long as it's going to hang this browser, so I have to do something and do here to stop. Okay, stop loop. Okay, it has stopped. So it's printed millions of zeros, gazillions of zeros, even within these few seconds. So something is wrong with this code. So what we're going to do is, for each time it prints x, we want to increase the value of x by 1. So we can say x equal to x plus 1. So this way we have increased the value of x by 1. So for each time x comes around, so the first time it's going to come, x will be 0, right? 0 is 0 less than 10? Yes, it prints 0. Then it comes here and says x is equal to 0 plus 1, which is 1. Comes here and says, is 1 less than 10? Alright? Yes, it prints again and adds 1, it becomes 2. Is 2 less than 10? Like that. Okay, so let's run it. So what you see is, it prints 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Interesting. 2 problems. We want to print 1 to 10, not 0 to 10, right? So what's the first correction we can make? We'll make the first correction as put x as 1. If we run it, it prints, let me increase this. Okay, so if we run it now, it prints numbers 1 to 9, alright? So second correction is, why is it not printing 10? Because by the time it adds, let's say the 9th time, it says, is 9 less than 10? Yes. It prints 9 and then it adds 1. You understand? So that one now that it adds, if it comes back again, it will now say is that one now it adds, it will now be 10. Okay, so now say is 10 less than 10? No, 10 is not less than 10. So it terminates. This is why it stops. That's why it's not printing 10. So how do we make it to print 10? 2 ways. One easy way is, first of all, let's make a little mistake. What if you copy this line of code and put it on top of here? So it checks, is starting from the beginning, is x is 1. Is 1 less than 10? Yes, it comes here and says, okay, 1 plus 1, that's 2. It prints what? 2. Comes back again, is 2 less than 10? Yes, it says, okay, 2 plus 1, 3, prints 3. So the first number is going to print here, it will be 2. Look at this. You see, the first number is 2. So we are still trying to make it print 10, right? So if we reduce this to 0, what will be the first number it's going to print? Try and pause this video and guess. Okay, so I think guessed. Let's run it. So the first number is 1. Alright, so the first number is 1. Now, interestingly, let's make it print 10. You will do is less than or equal to. Okay, less than or equal to. Okay, in this case now, even with this, it's printed easily from 1 to 10. You see, first number is 1, because here it says is 0 less than 1. Yes. Is 0 less than 10? Yes. It prints 1. 0 plus 1 prints 1, and so on. So writing this code like this works perfectly well. It prints 1 to 10. If we put this below, like we had it before, it's not going to work perfectly well. It prints 0 to 9, and let's change this back to 1. Run it. It prints 1 to 9, but then if we put a less than or equal, and run it, it will give us 1 to 10. Okay, so you can also use this. Alright, good. So let's do an interesting challenge. That's a challenge that let's write a piece of code that helps us print even numbers only. So assuming here, instead of printing 1 to 10, we want to print only the even numbers. Only the even numbers. So we want to print 2, 4, 6, 8, 10. What do? pause this video, look at this code, and try to think of what the solution could be. Just look at this code, okay? Try and think it through. And the way to think in programming is to place your finger on the screen on each number, and try to voice out what the value of x will be at each stage. So you run your hand through each step and say, okay, if x, put your finger here, okay, the value of x here is 1, then you say x is 1 less than or equal to 10, you say yes, you bring your finger to this place and say print 1, okay, so you write it down on a sheet of paper, the first number you're going to print is 1, and say, okay, 1 plus 1, 2, is 2 less than or equals to 10, like that. So if you keep writing it on a sheet of paper, you'll get this. Now we're trying to print only even numbers. One easy way, of course, is to just change this to 2. Alright? Is that the solution you came up with? So if we run this, what do we say? No, instead of changing it to 2 here, we can change it above. So copy. Now note that here it printed only odd numbers. So it printed 1, 3, 5, 7, 9. Okay, but if we put it above, it prints only even prints 3, 5, 7, 9. Okay, so if you wanted to print odd numbers, it's simple. Just put this here the way it was before, incrementing by 2. Now, what we can do to make it print even numbers is to reduce this to 0 and run. Print 0, 2, 4, 6, 8, 10. Okay. Now 0 is not an even number, but since 0 is not an even number, what do we do to make sure that it doesn't print 0? We do something interesting. Remember this guy. If x equal to 0, okay, or we can say not equal to 0, print. Okay, so as long as x is not equal to 0, do your printing 10, okay? So put this column here. Isn't that smart? So let's run and see. You see, it skips 0 because we have put the printing inside an if statement saying that only print when x is what? Not equal to 0. So the first time it's going to come through, x will be equal to 0, so it's going to skip the printing, but then it will add 2. Alright, because this 2 is outside of the if statement. As you can see, this print is inside. Is this space that tells you which one is inside which. This if is inside this while. Okay, this one is outside, so I can as well give it space so that you can see something like this. Okay, so what if you wanted to print odd numbers? What would you do? The same thing, but we'll kind of reverse it. Alright, now another way to find out even and odd numbers is a popular question in programming languages when they say print even and odd numbers between numbers 1 to 500, whatever. They want to see how you want to approach it. So if you write it this way, this is kind of a layman's way of writing it. Another way to write it is, remember modulo. Okay, in mathematics we have plus, minus, multiplication, division. There is something else called modulo. That's the percentage sign on your keyboard. This modulo, if we do, for instance, 4 divided by 2 will give you what? To give it 2, right? Now, if we do 4 modulo 2, that is 4 divided by 2, and modulo will always give you the remainder. So modulo will do 4 divided by 2, which is 2. Remainder what? 0. Okay? So if we do 6 modulo 3, will be 0, right? Because 6 divided by 3 is 2, remainder 0. But 6 modulo 4, 6 modulo 4 is equal to what? 2, right? 6 divided by 4 is 1, remainder 2. So modulo will always give you the remainder as the answer. Okay? So now, knowing that an even number is defined as a number, any number divisible by 2 with no remainder. That's what an even number is. Okay? An even number can be divided by 2 and there won't be any remainder. No matter how large the even number is. Like 1000 is an even number because if you divide it by 2, it's going to give you 500 on the dot, no remainder. Okay, but 1001 is not an even number, because if you divide it by 2, it's not going to give you, it's going to give you a remainder, right? It's going to give you 500 remainder 1, right? Okay, so if you're trying to print only even numbers, one thing you can do is to check the modulo. You can say if x modulo 2 is equal to 0, that is if it's an even number, right? X modulo 2 for every even number is 0. Print x. Okay, then we increment x by 1. Simple. So let's run it and see. You see, x modulo 2, it prints this. Now another thing I want you to do is, like I said, of course, to eliminate the 0, you can always put this on top. And boom, you eliminate the 0. Okay. Another thing I want you to take note of is, in programming languages, instead of doing x equals to x plus 1, no, you can do x plus plus. So if you do 2 plus signs like this, in most programming languages, this means increment. Alright? But another thing you can do is to say plus equals 1. If you say x plus equals to 1, it means whatever was in x, just add 1 to it. Okay, so note what plus equal sign is. Alright, so if I run it, you'll see that it's the same, exactly the same. So what if you want to print only odd numbers? You say not equal to, right? It's oops. Say if x modulo 2 is not equal to 0. Not equal to question, exclamation mark, not equal to 0. Say print only odd numbers. Alright, note that it printed 11 for us here. Okay, so okay, see, fine. Prints exactly the odd numbers. Alright, what else do we do here? If you want to move backwards, okay, let's move back. Let's print backwards. Let's print numbers from between 10 and 1. Okay, this is a print numbers between 10 and 1. Okay, as countdown, like as a countdown or something. Basically, what I'm saying is print 9, 8, 10, 9, 8, 7, 6. So I want you to pause this video and write a code using a while loop that will print backwards. Okay, and try and run it, and then you come back here to see how I will write it. Okay. So this is how I would write it, okay? So first of all, since we're printing from 10 to 1, I'll set x to 10. Okay, and say as long as while x is greater than 0, alright? X minus equals 1 and print x. Okay. X minus equals 1, print x. Good. And run. So let's run it first and then we'll explain. Print 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay. So first of all, that is not exactly what we want to print. We want to print from 10 to 1. So what do we do? What if we say greater than, what if we say this? Okay, print from 9 to 1 correctly, and here instead of saying x equals to 10, what if we say x equals to 11? It prints from 10, 9, 8, 7, 6, 5, like that. So this is perfect, right? So tinker around to see other ways to achieve the same thing, alright? But the idea is that the x is now starting from the top, and we're saying as long as x is greater than 1, keep printing. Okay, for the first time it runs x is equal to 11. Here it checks is x greater than, is 11 greater than 1? Yes. So it does 11 plus 1. 11 minus 1, because here we now have a minus, right? It does 11 minus 1, which is 10. It prints 10. That's why 10 is the first. You see? Then it comes back again and says, is 10 greater than 1? Yes. 10 minus 1, 9. Print 9. That's how it got here. And so on until it gets to 1. So when it gets to 1, it says, is 1 greater than 1? No. It stops. You understand? So this is how to print in reverse. What if you want to print even numbers in reverse? I'll leave you to do that and I will not solve it, okay? Because we have already done it the other way. print even numbers in reverse, print odd numbers between 10 and 1 in reverse. Okay. Alright, so right now let's build a guessing game. So basically, let's start with this. So what's a guessing game? We want the user, we have a secret number, or a secret number, then we want the user to guess that number, okay, through their input, okay. So we're going to say secret number equal to what? Let's guess it. Let's say our secret number is 4. Then we tell the person, guess, we can say equal to input, guess any number between 1 and 10. Okay, so I can say print guess. Okay, let's say so once we print guess, we say if guess is equal to, we say if guess is equal to 4, print you guessed right. We don't need to print this. You guessed right. The elif or else print you are wrong. Okay, so this is a very basic guessing game. So let's run it first. What is this? 2 week warnings. Where are the warnings? Oops. Okay. I put semicolon. What else? Here. Says there's a warning here. Okay. It says there must be a new line. Okay. All right. We're good. So always pay attention to this part of your code. This is where most of the warnings will be. Okay, 1 week warning. I wouldn't know what that warning is. So, but let's run first. We'll run. So guess any number between 1 and 10. So I'm going to guess, you know what, I want to put space here. Okay, to make it look cool. So, stop and rerun. Okay, cool. So I'm going to say 5. Hit enter. So it's 5. You're wrong. So I printed 5. Okay. I say you're wrong. You know, another thing we can do is to you guessed. Let's guess like this. Okay. So we rerun. It says print any number. Guess any number between 1 and 10. I guess 8. So you guessed 8. You are wrong. Okay. So how did it choose? It says if we chose 4. All right. Now this is a guessing game, but the user, it only asks the user once and it stops. What if we want the user to try 3 times before it stops? What do? We have to put something inside the while loop, right? So let's copy out this and write a while loop. Okay, we want it to be tried 3 times, right? So the first thing we do in a while loop is set the variable. So we can call the variable how many tries, number of tries, whatever you want to call it. We'll say equal to 3, right? So we can say while number of tries is less than 4. You know, 3 is less than 4, but 4 is not less than 4. Okay, so less than 4. Okay, we're going to do this, and then at the end, outside the if statement, okay, number of tries. We want it to be at 1 first to start. Okay, so we can say number of tries plus equal to 1. So we add 1 to it at the end. So initially, number of tries is 1. Is 1 less than 4? Yes, it runs this thing and adds 1. So it becomes 2. Is 2 less than 4? Yes. It runs this the second time and adds 1 again, it becomes 3. Is 3 less than 4? Yes, it runs it the third time and adds 1. We now have 4. Is 4 less than 4? No. It stops. So put your semicolon here though. I'll click this. It asks, guess any number between 1 and 10. I'll say 9. Say You guessed 9. You're wrong. Okay, so let's there's a problem with this code, so let's fix it. The problem is that the question is being asked outside, so let's ask it inside the loop. Okay, the main question. So we do this here. So we collect the number from the user, alright, and we try to run it. So there are still some modifications we have to do, but I just want you to take it step by step. Okay, so when the loop runs the first time, number of tries, when it runs the first time, it asks the question, and if the thing fails, it comes back again. Okay, so let's try. Guess a number between, I say it's 8. Say 8, enter. So you're wrong. Guess any number between 1 and 10. I can say 0. So you're wrong again. So let's fail again and see. We'll fail 8 again. It says you're wrong. And it terminates. Okay, this is it. It's not asking me again. So our loop is working well. So let's try and get it correctly at least the second time and see whether the loop will still continue, right? Okay. So we run the code and we say any number between say 9, 99, okay, wrong. And we get it correctly this time. Remember the secret number is 4, right? So we'll say 4. Guess whether it's still going to continue the loop even though we already have it correct, alright? So hit enter. It says 4. You are wrong. Why did it say you are wrong? Because here, the reason it told us that you're wrong is because we're using an integer here, but this particular command prompt accepts strings. So we have to convert this to a string. Alright, so we have to put it in quotes, and quotes. Alright. So we run this and say, let's say 99. Second one, we get it correctly, which is 4. Hit enter. You see that it says you guessed right. Okay, for the first time, this if statement runs correctly, okay, or comes true, but then it still asks us again. It continues the loop because the only condition that we gave it for the loop to stop, the only condition we gave it for the loop to stop is this. Alright, so even though we have already caught it correctly, the number of tries is still not up to, does not still fulfill this condition. So it still asks us again. You understand? So we need to be able to stop this loop once we get the correct answer. So in programming languages, there's a keyword to stop a loop. Alright? No matter how many times it's looping, once you find what you want, that keyword, you put it in an if statement and use it to stop the execution of that loop. There's also another keyword to use to jump to the next iteration. Okay, let's say that something is supposed to loop 10 times and you get to loop number 7. You don't want to do loop number 8. You can jump it. There's a keyword that you do to jump it. For instance, if you're trying to print everybody that has paid school fees and you get to somebody that has not paid, you want to jump. You don't want to process the code. You jump the person and move to the next iteration. So those two keywords in Python are alright. So here, those two keywords are break and continue. Okay, so we have break and then we have continue. Alright. So let's try here. What does break do? Break terminates the loop. Okay, no matter how many times it has run, once a break statement happens, the loop is terminated. So we're saying that here, if the guess is equal to 4, stop the loop immediately. That's what break does. But continue will skip that iteration. Okay. So let's see. I'm running this. Guess a number between 1 and 10. I guess it correctly. 4. Enter. You see? So you get right, but then it has terminated the loop immediately. See, process finished. That's it. There's no more loop. Alright. Now what if we say continue? Continue. Continue would have been a good example in when we were printing numbers 1 to 10 so that you can see that the number is skipped. We'll continue. Alright. And we run. And enter 4. If we enter 4, it's asking me the question again. It says you did right, it skipped. Okay, so it has skipped one iteration, but the way we'll find out is that the total number of questions it will ask us will not be up to 3 again. So let's say I enter 9 here. Guess, okay. So continue skips an iteration, you see. The question here is, why did it run many times? Look at this, it ran 4 times, right? Because once it sees the continue keyword, alright, your loop stops at the continue keyword and jumps to the next iteration here. So in this case, our loop never got to this point where it's supposed to increase the iteration. That's why it ran again as if it has not even increased that. You understand? So continue will pause the function. So the kind of the kind of loop we wrote is such that it printed extra, alright, because it paused and never got to this point. Alright, so if we had this number at the top here, then the continue would have a different behavior. Okay, so we'll run here. I said any number between 1 and 10, we'll say 4. So the continue has 1 now. Okay, so let's say it asks us one more time, 5, and then 7. You see? Alright, so let's look at something else. While it's not the only type of loop, okay, let's look at for loops in Python. Now we've seen while, so as usual we just do new and then we do loop of for.py. Okay, so here a for loop is essentially just like a while loop, but then it's mostly for looking through lists, arrays, you know, and stuff that are packed like that. Okay, rather than just counting a variable like while loop. So let's create a list. We can say sports. Okay, how many sports do we have? We have badminton. Did I spell it well? We have football. We have basketball. Basketball. Have last one, volleyball. Okay, so now we have that. Let's look through this and print them out one by one. Number one, if we do print sports, okay, and make sure we enable this file down one. Look for it to print it this way. Let's say we want to print it one after the other. All we're going to do is we can look through each one and print each one. So we can say for. When you write a for loop, you have to define a variable. Come up with any variable. So for now, I'm just going to put x in those sports. Okay, then do something. Print sports at location x. Okay, so that's how you do that by run. There's a problem with what we have, so we just first of all, for now, let's print sports. So as you can see, x is occurred 4 times in sports, so we our printing is printing sports 4 different times. Okay, we need to print the actual contents or the elements inside sports. Okay, so what we can do is we print x instead. We'll do print x and we run. Boom, we have badminton, volleyball, basketball, and whatever. So that's how to use x. Okay, now remember that I told you at the very beginning of this course that Python sees strings as arrays too. So for instance, this string is also an array in Python, array of characters. So let's say there is a first name equal to Dave. Okay, we can do for x in first name, print x. What is it going to print? It's going to print the characters, each and every one of the characters one after the other. I see D-A-V-A. So that's it with strings. So whenever you want to manipulate, work on strings, just know that Python sees it as lists too. Now, what of multi-dimensional arrays? Okay, or how do I put it now? And before we even do that, just know that you can use break too. We can say if x equals v break. Okay, so not winnable, we can put this here. So basically what this says is that as you're looking through this, each and every one of these name, when you get to V and you see it, stop this loop. Alright, remember that this is a loop. It's going round. Once it says break, once X has equaled V, it should stop the loop. So let's run it. It says DAV and it doesn't print E. So that's the use of break and continue. What if we change it to A and then do continue? Alright, let's see what happens. Prints DAVA. Alright. So because the continue did not have any effect because the print statement is above. What if we put it below outside? Okay. Not outside the for loop, but inside outside the if statement here, like this. So this is still inside the for loop because look at the space. Alright. So this if statement will stop if X equal to A, otherwise it will continue to print this. So let's run it again. And we'll see that it has stopped, alright. It did D, V, it skipped A because X is equal to A. It figured out that X is equal to A, so it stopped and jumped to the next iteration where X equals to the rest, okay. A keyword in, there's a keyword in Python that is called range, okay. I'll call it a function. So range kind of helps you to run through, usually used in for loops, helps you to run through an iteration depending on how many times you want to run through the iteration. Okay, so we can say for X in range 6. Okay, range starts from 0 to count. Okay, you can say print X. Print X. Oops. Print X. Okay, so if I delete this. For X in range 6, print X. Okay, we'll run this. It's gonna print 0, 1, 2, 3, 4, 5, 5. It doesn't print up to 6 because it starts from 0 to count. So it has printed 6 numbers, but actually the number started from 0. So that's what range does. So let's try something. You can start from a certain number to a certain number in range. So let's say we print from 3 to 6. Range 3, 6. Okay, if we run it, it's going to start from 3 and end at the 3rd position. This is actually a position, starting from the 3rd position and ends at the 6th position. Okay, so what if we did range 20? So it's going to start from the 3rd position and end at the 19th position, the 20th position, which is 19. Good. Now what if we want to skip every 2 numbers? Okay, we'll do comma 2, skip every 2 iterations. You see, it does 3, 5, 7, 9. So this is a shorter way to print odd numbers and even numbers in loops. You remember in while loop we have to do a lot of thinking to arrive at this, but in for loops, just with range you can do anything you want. So we can say start from 2, get to 20, but skip every 2. Start from 2, get to 20, say okay, print. You see 2, 4, 6, 8, 9, 10, like that. Okay, so that's how range works, and it's used in for loops. But also you can use range in arrays. Okay, so let's say this sports. Okay, let's see what happens. Can you guess what's going to happen? A little error here. So by now I know you should be able to read a Python errors. So it says list object cannot be interpreted as an integer. So this is a list, right? So to make it an integer, what do? We have to find the length, right? So length, and we'll run. Okay, see? So because there are 4 here, alright? What if you wanted to print a certain, you want to print the contents? It's okay, instead of printing X, you can say print sports at location X. Okay, since the first time sports will come, X will be 0. So sports at location 0 is what? Badminton, right? Second time, X will be 1, sports application 1 is what? Football. So if we run this, it will print badminton, football, basketball, and volleyball. Okay, so you can use range. Okay, what if you do start from 3? Start from 2, okay? 2, comma, length. This length gives you the length, okay? I hope it's not confusing you, because if I do here print length sports, okay? Let me comment this out. Commented it out. So if I say print length for sports, what do you think happens? It's going to print the total number of elements here, which is what? 4. Okay, 1, 2, 3, 4. You see? So in this our code, when we say range length sports, we're actually expecting a number here, which is 4. So we're saying start from 2, get to 4, but then print the contents, and we run. It prints what? Basketball and volleyball. Okay, so that's how you do it. Remember at the beginning of this tutorial that I told you about this function. Let's say to raise a number to power of another number. Okay, so let's say you want to do 2 raised to power 3. Okay, so how do you do that? So let's say print. I remember we did 2 raised to power 3. It did not work because it did 2 minus 3 instead. So let's run it first. So you see, 3 minus 2, that's what it did. Wrong calculation. But if you want to do raised to power, you use the multiplication sign twice. Basically on your keyboard, that's the asterisk sign. See? This means 2 to the power of 3. That's 2 times 2 times 2, which is what? Let's run. Gives us correctly 8, right? 2 times 2, 4. 4 times 2, 8. Good. Now, another way to do it in Python that we did at the very beginning of this course is power. The power, and then we'll pass 2 to the power of 3. Okay, that's how power works. 2 space. You have to space it correctly, otherwise Python will give you error like this. Then you hit enter. It gives you 8 again. Okay, so power is correct. Now, what if you are told to write a function? Because what does power really do inside? We don't know. Okay, but what if we are told to write such a function? So first of all, a function that takes 2 numbers, accepts 2 numbers, and does their iteration and finds out the power of the number. Okay, so let's write the equivalent of the power function. First of all, let's create a function. Remember how to create a function. Say def. What do we call this function? Raise to power, whatever. Okay, raise to power. Okay, this function will accept 2 numbers, the base and the power. That's what we're going to call the 2 of them. And then, now let's start coding. What happens when somebody passes 2 numbers? Normally, remember that 2 to the power of 3 is equal to 2 times 2 times 2. Alright? So now, what if somebody wrote 2 to the power of 13? We can do 2 times 2 times 2 times 2. No. But we can use a loop to count how many times we have to loop, right? Fair. So we're going to say, let's declare a new variable and call it answer. Okay. Answer equal to the base to the power of what? The power. Okay. That's it. Print answer. So let's call the number, the function, and say def. Remember, you have to put 2 spaces here, otherwise you have an error. Okay, so we say raised to power 2, 3. Okay, and see what it's going to print to us. It prints 8. Fine. Okay. What if we wanted to use a loop and do this? How are we going to do it? You can say for x in range power. Okay. Let's print x first so that we'll see what's inside. For x in range power, let's print x. Gives better. is this? Indentation is not a multiple of 4 because we didn't indent properly, so I'm going to come here, hit enter, and then the indentation is proper. Do the same thing, hit enter, and it's proper. So Python is very indentation sensitive. Okay, so let's run. So we're trying to print X first of all to see what's going on there. It prints 0, 1, 2. Okay, so we wanted to print 1, 2, 3. Okay, that's what we wanted to print. So we can say print X plus 1. Let's just see. It prints 1, 2, 3 correctly. Okay, good. Now we can do our calculation. We can do base. For each of these, we'll do base times base times base. Okay. Alright, so we can do answer equal to base times base. Alright, for each of these. So here we're going to do answer equal to 0 to initialize it so that the answer is 0. I think we have to do another space here. Okay, so every time you want to write a function, you have to put 2 spaces, and after it, you have to put 2 spaces. So what's this thing here? Shadows name outside from outside scope. Okay. Another thing we can let's comment this out first. Okay, so at the end of the day, at the end of the if statement, we want to print answer outside it. So print answer. Okay. So what is this doing here? Too many blank lines because they don't expect us to have a blank line. Oh, for both. We're not supposed to have all these blank lines. Okay, good. So let's run print 4. Okay. Printed 4 because each time we're overwriting the contents for each loop, we'll do base times base, which is 2 times 2, and then we'll save it here to be 4. But when next it comes, we'll do the same 2 times 2 and overwrite this again. So it's not proper. Let's rescue the situation. So we'll do answer equal to what now? Can do 0 here for 1. Before the loop starts. So the loop starts here. It says loop has to loop 3 times. The first one, it says answer equal to base times a base. Instead of base times base, we do answer times base. Now I think generally instead of putting 0, because 0 times anything is 0. So let's use 1. Let's try it first. And it's correct. So if we had used 0 here, it would have been nullified the whole multiplication because it will be 0 times anything. That thing will be 0. Okay, answer will now be set to 0. But if it is 1 times anything is that thing. Okay. So let's try another number, 2 raised to the power 4. And see what it goes. Say 16. Works perfectly well. Okay, so this is one way of using iterations. It doesn't matter how many times, how many power the person puts there. This is one way of using iterations to or for loop to solve a problem. So I'm going to go over it just one more time. So we created a function, and what the function does is it takes a base, which is something like 10, and takes a power. Okay. Now, for each base and power we're given, we look through the number of times the power is. If the power is 4, we created a loop that will go 4 times. The assignment I'll give you in this video right now is to try and use a while loop to do this. Okay, do it in the while loop way. You can backtrack a little to see how while loop works from our previous video. Try and achieve this thing using the while loop way. Okay. So here, we'll loop the number of times the power is. And for each loop, we take the previous value of answer and multiply it by the base. So the first time this will loop, we'll do base times 2, which is 1 times 2. That will give us 2. We'll come back again, and then we'll do 2 times 4. That will give us what? 8. Then we'll come back again. We'll do 8 times 2. Sorry. The very first time is going to go, we'll do 1 here, that is here, 1 times 2 to give us 2, alright? Come back again, answer is now 2, so we'll do 2 times 2 again, because the base is always 2, okay? It will be 4, then we'll come back again, we'll do 4 times 2 again, so we'll just keep multiplying by the base. So in this case, we were given 10, so the base is always 10. We'll do the first time to be 1 times 10, that's 10. Go again, 10 times 10, that's 100. It will go again, 100 times 10, that's 1000. It will go again, 1000 times 10, that's 10,000. That's why you have 10,000 here. Alright, then we'll print for each at the end of the whole iteration, we'll just print answer. So this is where the iteration ends, then we'll print answer. Okay, then we'll call a function here and pass in any variables. So try and do this with a while loop. That's an assignment. Another thing you can do is instead of just printing the answer here, why not take these inputs from the user, ask the user to enter base and power, then you run this function to calculate and spit out things to the screen for the user. Alright, so try and do that too. Alright, let's try one more thing, multi-dimensional arrays, or sort of two-dimensional arrays, okay, or loops. Okay, nested loops, that's what we're looking for, not multi-dimensional. Nested loops. So nested loops are used to loop through multi-dimensional arrays. So far, all the arrays we've been seeing is just single dimension. So for instance, fruits, we'll do apple, mango, cashew. But what if inside cashew, there are different types of cashew? Inside mango, there are different types of mango, like other breakdowns. That's multi-dimensional. We're going to see it, but let's look at nested loops first. So let's say adjectives. I've forgotten the spelling of adjectives, so let me take a shortcut by doing adj equal to somebody can be tall, dark, and handsome. Okay, this guy can be slim, fat, and short. Okay, good. Now let's look at names of genders or people. Okay, so let's say people, and we can start saying man, woman, child, youth, and so on. Alright, and first of all, let's complete it, make sure that they are equal. 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, and go. Okay. So we can use a for loop to say things like tall man, dark woman. But I'm just trying to show you that you can use a for loop inside another for loop, and same thing with while loop. So they are called nested. Okay, nested for loops. Okay, so let's try it here. We say for x in adj, okay, for x in adj, and then so for each time x in adj, so it has started looping, and we're saying for each loop, each time it loops, complete this. Alright, for x in adj, we can say print for y in people, You get the idea now. So for each time, we'll print this. So print x, okay, and then we'll print y too. So let's see how it goes. So what do you think is gonna print? Okay, let's look at it one more time before we print. For each x in adj, so if you're coming from other programming languages, for is the equivalent of for each. Okay, so say for the first one it says tall. Okay, and then it also loops the first one in people and then prints. Okay, so let's see. So you see what happened. It says tall man, tall woman, tall child, tall youth, tall girl. Then it moves to dark. It says dark man, dark woman, dark child, dark youth. You understand? So for each time the outer one runs once, the inner one will run complete. That's what it means. For each time the outer one runs once, the inner one will run complete. So many times I've had to use this so many times in my programming. So many times. Alright? Especially when you are retrieving data from the database, you have to start looking for each student. Go look for all their results in their certificates. You know, for each church, go find all their members. For each this, okay? You understand? So this is a very useful concept if you understand it. It's simple. For each one on the outside, go get everything on the inside on the second loop, okay? Then you go back for each one, then you get everything on the second loop. That's basically what it is. Always, programming is about curiosity, right? So let's try something. We say, what if they are not the same number? So what if there is 2 missing here? Okay. And what do you think? First of all, look at this and tell me what you think is going to happen. Alright? Just observe it and think about what's going to happen. The two arrays are not the same size. Okay? Have you completed? Let's run the code. Boom. So basically, nothing really happened. They just did less iterations. So it says tall man, tall woman, tall child, tall youth, tall girl. Comes back and says dark man, dark woman, dark child, dark youth, dark girl. Something handsome, blah blah blah, slender, and then it stops. Okay. So once the outside loop stops, the inside loop will also run its last iteration and stop. So that's basically what happened. So let's look at another way of working with nested loops, and that is multi-dimensional arrays. So let's look at a multi-dimensional array. So seems I'm going to use a number to do that. So let's use a number. Let's say scores for a number, and then we'll open a list, okay, and then we'll say here there's another list inside the list. So we can say people scored 1, 2, 3, and 4, okay, comma, and then we'll do the same thing again, 5, 6, 7, and 8, comma, the last one, we'll do 9, 10, 11, and 12. Now, I hope this doesn't confuse you, because before, what we used to have is single dimensional arrays that would be 1, 2, 3, like that, 4, and so on. So this is what we used to have, but now, as you can see, at least some of them would have multiple dimensions, like this. So this is the equivalent of what we did. Alright? So we're saying amongst this, sometimes one of these could be an array. So we denote it with this, or a list. Okay. Alright. So good. Now we have this list that is complex. Just look at it as let's make it equal to start with, not to confuse you. Okay, it's actually equal. Alright. So look at this as an Excel sheet with rows and columns. Okay. So we want to do a loop. Can you do a loop that will print this with 2 loops? Okay, because you need 2 loops, one printing the rows and one printing the columns. So pause this video and attempt it, okay, and then we start to see how I solved it. Alright, so look at how I solved it. So we'll do for x in scores. Alright, so now I'm going to, for x in scores. So, but let me change this to rows. So because this is a row, right? I'm saying this as a row and a row and a row. Just for the purpose of this video, so I just chose rows. It doesn't mean you can't choose anything. So for each row it goes to, because if we do for x, let's do this first. Print rows. Okay. Print. You see that it prints this after every comma. So to make it easier for you to understand, we can put all in one line. Alright, just put everything in one line so you have an idea based on what we had before, you see. Okay, so for each time it sees a comma, it considers this as one value and prints it out, then moves to the next comma, print it out, move to the next one and print it out. Okay, so now, but we also want, for each time it gets to this point, we want to loop through this one again and print the content. So we're going to say for each rows, we can say another for each column in rows, because each row is now an array on its own. So we can say each column in rows, print what? Column. Okay, so it is. So it gives us all the columns, but we can also print row, comma column, and rows. Sorry, rows, comma column. Okay, so you see. So you can manipulate this array in so many ways and print all the contents the way you want. Okay, depending on how you want to arrange your printing statement. But this whole thing just shows that you can look through, alright, and then print. Okay, so another thing you can do easily is print the rows separately and print the columns separately. Okay, so here, so what it does is it prints the rows. For each time it loops, it prints whatever is in the row, and then it takes time to print whatever is in the column. Another type of array we can have is items. Let's say we create a variable called items, and then here we say something like we can use what do you call it? We can use strings, because here we just use numbers. We can use strings to do people level and so on. So just know that the fact that you, let me call it scopes. So the fact that you have different variable types doesn't really mean anything. Okay, as you can see, printed volleyball, football, and then 3 and 4, you see, and then went ahead to print the contents, and then like that. Okay, so the variable type doesn't really mean much. Guys, we've always seen errors when we run our code in this tutorial. We see error in red. Now, have you ever asked yourself what happens in a real-life program, alright, where a user encounters an error? We don't want all that red error message popping up on the screen. How do we contain that? Alright, so let's say I do print x. Okay, print x, and then I run it. Oops, I have to select this. Run, try accept. You see, it says x is not defined. So we don't want this to show up on a website. Imagine visiting a website and you see all these error message. We don't want it to show up. So how do we hide it? So we can put it inside a try statement. We say try, colon, then we write a code that has to be inside try. So if you are ever writing a code that you feel that might go wrong, alright, use a try, then put accept. That if it should try to run this, if it encounters an error, then it should do this one, print sorry, our engineers are busy. Okay, whatever. So that's accept. So we run. Instead of throwing that error now, okay, because x does not exist, it gives us sorry, our engineers are busy. Okay, try later. So the reason it's throwing an error obviously is because we didn't define x. If we define x equal to 1, 2, 3, and we run it again, what you notice is that the try runs, but the accept doesn't. Okay, so that's how it is in Python. In some other programming languages, it will be try, catch, and finally. Now, Python also uses finally. So finally means just do either of accept or try, If try works, fine, then skip except. If try does not work, okay, use except. But also, whichever of them works out, make sure that at the end of the day, you also run the coding finally. So what if we say finally, or whatever, okay, so we just print this. You see that even though the try run, they finally also run. So finally will always run. So if you're writing a piece of code where a certain part of it will always run, okay, irrespective of whether there was an error or not, you use finally. Now exception can have a number of values. So for instance, value error. There are different types of exceptions. If you want to be really specific on errors, for instance, if the user entered the wrong input, you want to put like something like an error that has to do with wrong input. What if they entered a 0 value, they put string where they're supposed to put an integer, whatever. So there are many types of exceptions, and you can also use variables as exceptions. So you can define a variable here, and then you use the variable here. You can just say var. So this way, Python allows you to build an error message with the actual error. Okay, so most programmers will use error, ERR. Okay, it's just a variable, so that you can include it in the message you want to spit out to the user. Another thing is that you can have multiple exceptions. Okay, depending on the error type. Okay, you can have an unlimited number of exceptions depending on how things are going on with your code. Okay, so exception. You see, there's base exception. There are so many. Just go to the Python documentation. You see all the different kinds of exception. But basically, if you don't put any variable, it just throws for any error at all that happens in any code you put here, it will catch it. Okay, the exception will catch it and throw it. But if there are different possible kinds of errors that will happen, you can have multiple excepts and different exception variables. And at the end, it's optional, but you can also have finally. So that's the try catch. Alright, so let's look at how to work with files in Python. So let's create a domain file and call it, what do we call it? I'll call it zoo.txt. Zoo.txt. Okay. So in zoo.txt we would have king of the forest. Okay. King would be, what do you call it? Name. Okay. King would be lion, and tall will be giraffe. Okay. I forgot the spelling. Fast will be cheetah. Fast will be antelope. Unfaithful will be cheetah. And one last one, which other one? Tricky will be monkey. And what else? Alright, lazy will be sloth. So let's say there's this file somewhere that has all this, alright? Can we read the contents of this from another file in Python? So let's create another file and call it file manipulation, okay? Py. So that's the topic we're covering here. So file manipulation in Python. So there's a simple function that you can use to open and access files in Python. It's called open, okay? Then you put the address of where the file is on your system. So in our own case, since this current file manipulation.py is in the same folder with the zoo.txt. Okay, so I'll just do zoo.txt. You see, we can it will just read it, all right. But then there's about 3 to 4 different modes in which you can open a file in Python. The first mode is that you're opening it to read it only, just to read. Okay. Second is that you want to write, only write. Third is you want to either read or write. And fourth is the A, which means you want to append. So here we're just going to equate this to a variable and say zoo file equal to open. And we have to open it in a certain mode. We can say open it just to read it. That's R. Okay, remember that we have R, W, R plus, and A. So those are the different options you can put here. So for now, we're just opening it to read it. So first of all, there are some functions that come with reading files in Python. So the first function is once you open a file, you also want to close it. Okay, so I'll do zoofile.close. So if you ever want to run a function, work with files, once you open it, make sure you close it, and every other code you write about that function will be in between. Now, another thing is, a good life example is when you want to scrap the web pages, other web pages. So let's say there is a certain website like twitter.com, and you want to write a Python code that goes to Twitter and reads whatever is there, fetches it to you, and then maybe help you fish out something. Like when you write a code that goes through a website and fetches all the emails people posted there, like a forum. So when you go to the website, you want to first copy all the text there and put it into a certain file. Okay, then you can use commands like this to start looking for what you really want in the file and fish it out. Okay, so but before you do anything, you want to find out whether the file is actually readable or whether there was some error. So how to do that? You say is this. You say readable. So this will always return a true or false statement. So if you say print zoo file readable and run it, okay, we have to select it here. We have to select this and then file manipulation and run. See, it's telling us true because the file is okay. It was able to access the file and it was able to read it. So one other function we can do is .read. .read actually tries to read the content. Okay, so .read goes to the file and spits out the content. You see. Alright. So the next thing we want to look at is .read lines. Okay, so first of all, .read line. So when it's singular, it reads the very first line in the file. So if we say this, see, it shows us, it gives us the very first line in the file. And the funny thing is that if we repeat it again, print the same thing, it will also read the second line. So the second call to this will also print the second line. So if we run this, now we have to, alright, same thing, repeat it again. So no matter how many times we do that, it will always read. Now, an interesting thing, a pattern we follow throughout this course is to try something. Okay, let's say we define a variable here. Say x equal to 36. Alright, print x. So guess what these extra lines will do if we interrupted the whole process in the middle. Alright, so as you can see, it didn't interrupt the reading of the files. Even though we read the first two lines and we did a calculation and printed x, alright, the next call to zoofile.print also printed in the very next line. It didn't repeat itself. And that's smart. Okay, so let's take out all this. Now, what if you wanted to read all the lines? You can also do, apart from using read, which we did before, look at read here. Again, we've already done that. Oops. Okay, it just copied everything and pasted for us here. But what if we do read lines, this time in plural? Read lines, and then we run. You see that it gives us an array of every item, every line in that file. It turns it into an array. Now we can work with arrays, right? Now we can work with arrays. So, or lists. Okay, so it has turned this line turns every single line in the file into a list. Now you can use a for loop to do something like for x in zoofile.readlines print x. You see? So these are, let me delete this. Okay. So we're looking through all the items, which are the different lines, and we're printing it out. So we run it, it gives us exactly this, you see. So those are the key functions. Let's look at writing, okay? So write, you do this. We've seen the different ways to read. What if we try to write, okay? So before we do write, let's do append. So remove this. So if you want to append, it's just appending a file is just a way to add extra information to it. Okay, so if you look at the zoo text, I'll duplicate it. You see that the last line there is lazy sloth, right? Okay, so come back to file manipulation, and we say zoo file.write. And remember that we opened the file in append mode. Now we can write zoo file.write, and we can say mosquito wicked, okay, or heartless. Malaria kills about 300,000, 100 to 300,000 people per year in Nigeria alone. So mosquitoes are heartless. That's where the malaria comes from. Okay, so we'll run this. See, nothing happened, but when we go back to zoo.txt, you see, it added mosquito heartless. Okay, so what if we wanted it to add to the next page? We can do another animal and say zoo flies weightless. Okay, so but this time we want it to have be in a new line, so we'll do /n. Remember that / will escape n, and it automatically inserts new line for us. So if we run this and go, we'll see that, you see, it is here already. So that's writing for you. But what if we change it to write mode? Alright, first of all, in append mode, you have to be careful, because every time your file runs, your code runs, it will run the append. So you have to be very careful. So if we look at this now, the last line is flies weightless. What if we run this code again, and maybe run it again and again. Come back to our code, you see, weightless, you see. So if you're working with files, you have to be extremely careful not to duplicate data. Okay, use a lot of if statements to be sure that you're doing what you're supposed to be doing. Now when you say write, if you specify a file, write will go into that file and overwrite everything with this. So look at this. We specified it, we'll change it to write, and we'll run this, and we'll go back to zoo.txt, and boom, everything is going except this. Okay. I want to undo it, so I did Ctrl Z. So that's what a write does for you. Another thing is that you can actually specify the file. When you do write, it will go and delete whatever file. If this file exists, it will delete it and recreate it and insert this inside it. So let's say you want to create a new file. You can say zoo1.txt and then run. Nothing happens, but what you notice here is that a new file has been created, and if we double click, it will now be zoo1. Okay, zoo1.txt flies weightless. So that's how write works. Okay, remember that if you want to open a file that you can read and write, you do r+. Okay, so that's how you can read and write. Yes, let's try and delete a file. Okay. To delete a file in Python, you can also use import OS. There's a Python library called OS. So once you import it, you will have access to all the file manipulation functions inside it. So the first one is OS. Before you let's find out if a path exists. Okay, if a file exists. This is how to do that. You just say os.path.exists. You see, it's already telling us what to do, and then we write the stuff. So in our own case, we're looking for zoo.txt. Okay, zoo.txt. Remember, this is in the Python documentation in case you want to read more. If you want to read more, it's in the Python documentation. Okay, just look for file manipulation there. So this will return true or false. So we can say print. If this file exists, it will give us true. So say true. So now we can use it in a statement. We can say if this file exists, then do something. We can say delete it. Okay. I'll do zoo1.txt. Okay, so we can delete it. os.remove. Okay. We now mention the file we want to remove, zoo1.txt. So now this will remove it. So we can do else. We can do print file does not exist. Okay, so let's run this. So the file was removed. You see it's gone, and that's why we did not say file does not exist. So let's try it again now that the file is removed and see what it will give us. So file does not exist. What if we do if this was removed successfully? Print. I know that's what's in your mind, so let's see what it will print. Print file removed successfully. Sorry, if is not supposed to have okay, so we check whether it exists. If it exists, we try to remove it. If we successfully removed it, then we say, hey, it was successfully removed. Otherwise, we say else print failed to delete file. We can say found file but failed to delete. We can say fail to remove. Okay, so you understand our code now. We'll first check whether the file exists. If it exists, fine. We try to remove it. If it doesn't, if we succeed, we'll say okay, file removed successfully. If not, we'll say it failed. But what if it doesn't exist? We'll tell them that file does not exist. So in this case, this file does not exist. So let's run first. It doesn't exist. But let's create it. Okay. Right click. New zoo1.txt. Okay, good. Now if we go back to our code, file manipulation, and run this code, so found file but failed to remove because this wouldn't run, but it removed, right? It removed. Let's try again. So the file actually removed. Right click and create a new file called zoo1.txt. And let's look at our code again just to be sure. If you find it, remove it. If you removed it, print that you removed it. File removed successfully. Otherwise, print that. Alright, it actually removed, but it's giving us this. Maybe this usually doesn't return true. Okay, so another way to do that is to check whether the file still exists. So we try to remove it. We can try to remove it here. So most of programming is about being able to solve problems on the fly. Okay, so see what happened here. We said try to remove it. Check if it is still there. You see? Always put a space. So here we try to remove it, and here we check whether it's still there after attempting the removal. Okay, and then let's run this. So let's run this run. We'll have to create the file again because it has been removed. So right click and new file, zoo1.txt. Okay, so we get back the file manipulation and run. So found file but failed to remove. I wonder why it's giving this error. Okay, I don't know if you can see my error in this code. By now, it should be a good Python program already. But the error is that here, we're saying, does this file exist? If it exists, remove it. Okay, then check again whether it still exists. If it still exists, say file removed successfully. So this is a problem. We would have said not. Okay, in Python you can do not. Check if it exists. If it doesn't exist, okay, if it doesn't exist, we can say this. Alright, so we'll create that file one more time. zoo1.txt, then get back to file manipulation and run. Oh, finally, we now got it. File removed successfully. If you don't understand what went on here, just calm down and look at it again. Check if file exists, then try to remove it. And if it no longer exists, say yes, it was removed successfully. Otherwise, say no, we found the file but we couldn't remove it. And then if it doesn't exist at all, say it doesn't exist. So this is the same way you remove directory in Python using OS. You can do new folder directory. Okay, directory, you can say my underscore folder. Okay, so there's this folder here called where is it? Where is the folder we just created? Seen it here. This is the folder we just created. So let us say we want to delete it. So we can use the same method to see if the folder exists. My underscore folder. Okay, this is the folder. If it exists, to remove a folder, you use remove directory like this. RMDIR, that is remove directory, and then say my folder. My folder, and then we check whether it still exists. My folder. And we say folder removed successfully. Folder. Okay, so here let's try and it's gone. See, our code worked perfectly well this time. Okay. All right, so let's look at a little more interesting concept in Python called lambda. So let's create a new file and call it lambda.py. If you ever heard of lambda, it just means that it's a way that Python generates a function or an argument and assigns it to a variable and allows it to call that variable as if it's a function. So let's say x is equal to lambda, okay, lambda a, and say a times whatever. Let's say we're looking at a times n, okay. So that's let's say 8 times 2. Okay. Initially, what we're trying to do is to write a function that anytime any value we pass into it, it will always be multiplied by 2. So how do we use this function? We say print okay. In the print we print x. So now, because the context of x was defined as a lambda, we can call x as if it's a function, and then we'll pass value of whatever will be here before the colon. So that is, let's say, 5. So if we print now, guess what it's going to give us? Keep your eye here. So let's run. 1 and lambda. So it gives us 10. So if you look at this lambda again, you see that it's in different parts. First of all, the main variable. This variable, you can only access it as if it's a function. So remember, when we want to call function, we have to write the name of the function. Okay, then we put these quotes and then enter the parameters here. You must put this double bracket if you want to call a function, which is different from defining a function. If you wanted to define a function, we do name of function. This is how we define functions in Python. So if you wanted to do the same thing, what we just did here, if you wanted to do it as a function, we will do name of the function. We pass in a parameter, let's say a, and do return a times 2. Okay, so here, if you want to use the function, we have to do double space. If you want to use the function, we'll just pass the value of a, which could, let's say, what did we pass here? 5. So we can say 5. Okay, and then we'll do print 5. So look at these two functions. Okay, look at these two functions. This is how lambda will handle it. Okay, we just define a variable as lambda. So let's start with here so that you understand very well. And secondly, you need to know that I don't use this often. I prefer the function type, but if you ever reading a Python code and you see lambda, I want you to understand what's there. Okay, and you might even find it useful in your own coding. So we said lambda. Once you define something as lambda, then you have to use a colon. Okay, you define the variables that should be the parameters. It could be one variable, it could be multiple. Okay, we'll give example of multiple variables soon. Then you put a colon, and then you put whatever argument you want, maybe some calculation or multiplication or whatever inside. Okay, so whenever you want to use the lambda, you have to assign it to a variable, so that variable is like the name of the function. So here we use x. Another thing we could use is name of function equal to. So here we simply use name of function. So let me comment this out because they're using the same name. And comment this out too. Okay. So here we declare name of function. Reformat. Okay. So do not assign a lambda expression. Use a def. Okay. So basically, don't mind that. This is how it works. The lambda expression you want, you have to equate it to a variable. Alright, so when you want to call the variable, you call it, but then you have to pass the parameters here. So here we could also do x5 and do a times b. Sorry, ab. Alright, so this is lambda, and we're saying the two parameters we want to work with are a, b, and then we'll put colon. Then this is the expression we want inside. Alright, so we take this whole thing and equate it to any variable of our choice. Now this variable becomes the name of the function. So whenever we want to use the function, we'll just call the name of the function and we'll pass in the parameters we want. In this case, we have to pass in parameter for a, which is 5, and then for b, which is 2. So this is going to print what? 5. It is going to print 5 times 2 times 2. You understand? So if I run it, it gives me 20. You see? So that's a lambda for you. It's not hard to figure out. Just know that it's a shorthand formula for defining a function. Alright? Nothing special there. So for me, traditionally, I would use this because of my background. Okay? I would prefer to use functions. But if you ever code anywhere, you will see a lambda, you should be able to understand what's going there easily. Alright? Guys, in this video, we're going to talk about modules in Python. So we're going to create a new file we call our source code. Source code. Well, let me not call that. Let me call it personal.py. Okay, so this personal.py, let's say it contains two things, a function, okay, a function to add numbers, okay, we give numbers A, we give B, and we say return A plus B. Okay, and then it has another thing inside, and this could be, let's say, a dictionary. You could say person1 equal to this dictionary. Let's say name Bombo. Okay, and then age. Okay, here it should be called age 37, height to do 6. Alright, so we have this. Okay, so we have this inside the sorting file. Now, can we gain access to these two things that we have here from inside another file? So let's create another file. We call module test. Okay, we'll just give it any name. So module practice or module tutorial, whatever. So from here, module tutorial, let's say we want to add two numbers, and we have that function inside somewhere, and this is how we can access it. Alright, you can simply do import. This is the file, so we import it from inside the module practice where we want to use it. We can say import personal. Python already knows what you're talking about. Okay, Python already knows you're referring to this file when you say import this. Okay, so now going forward, what can we do? We can do print personal dots. The moment we put dots, it gives us the two things we have inside personal, both a function and a dictionary. This is called a dictionary. Remember? Double click. This is called a dictionary. Remember from our past tutorials. So we're trying to access it from here. We can say once you put dots, PyCharm will show you exactly. So we can say let's add two numbers first. Personal.add numbers. Then we can say the first number should be 4, second number should be 5. So this should give us 9, right? Okay, so give space here and hit enter. Oh, we have to run this file. So I've made this mistake a million times. Gives us 9. See, so we can now access codes we wrote in other file from here. So what of the other function where we do person1? What if we want to print person1's age? Okay, we can say person1 age and print. It gives us 37. We can say name. Gives us Bombo Clark, Mr. Bombo Clark. So it's beautiful. What if we don't want to use personal as the name? What if we want to use another nickname for the file? We can do use the as keyword to say, we can do the PS. So now we can now use PS here. You understand? So if you see as, you would see that somebody can use a nickname for it. Okay. Usually when in your code it clashes. Let's say there's somewhere else in your code you're using personal variable and whatever function definition. So when you're importing another file that has the same name, you import the file but you change it, okay? Give it another nickname. Another thing is that you can import only aspects of a file instead of everything. Okay, sometimes the file you are importing from will have so many functions, hundreds of different things you can do. Like when we imported math, okay? You have so many things you can do, and you don't need all those things to make your program light. You can import only specific variables, functions, declaration. So we can say from, you use the from keyword. So So we can, in the from keyword, you can say from personal, okay? That's from this file. Import will now mention what we want imported. So in this case, we want imported person 1, okay? So do person 1, see? So it means that inside personal, we just imported only this one, and we'll never have access to this, alright? We just imported this. So once we imported this, now we can now have access. We can now say something like this. Okay, we use it directly without having to make reference to the module name. So if we run this, it gives us one more flag. Okay, what else do we have there? Height. So if we run height, so let's try and access add numbers that we know that we don't have access to. We say add numbers, add underscore numbers. You see, it's already underlining it. It doesn't exist. We don't have access to it. So that's modules for you. Now, we can. Python has hundreds, if not thousands, of. Python has original hundreds of modules that come with Python. Okay, you just import them to use them when you want to. Okay, that's Python for you. But also, the Python community is very large and very rich, so people have written lots of modules on their own. You can find on GitHub, and a whole lot of you can find on Google. So almost everything you want to do in Python, somebody has written a module on it. You just go there, read the documentation of the module, and implement it. You never have to reinvent the wheel. For instance, if I was building an app like Instagram that changes picture filter, you know picture filter, right? You're building an app like that when people upload picture, they can do filter, they can write on it and stuff. You don't need to write each of these functions by yourself. You just Google Python photo filter library. So let's go Google it. So you can do Python photo or image filter library or module. Okay, in this case it's called module. See? 10 Python image manipulation skills. Image manipulation module. Isn't this amazing? And usually they're all free. Okay, so you go to their documentation. Alright, this is the documentation. So we read it, how to implement it. So here, this is how to implement it from here, import image filter. And this is how to use it. If you want to blur the image, okay, if you want to, so they'll give you examples. You play around with it till you figure it out. It's usually easy. Look at the parameters you can pass in. So very well detailed documentation. You understand? So before you know it, you are doing lots of magic with images without writing the original code by yourself. So I don't think this is original Python. Somebody just wrote this. This is not from official Python. So if you want to get something from Python officially, you type Python module list or Python module index. Search for it. You see the ones written officially by Python, python.org. Click on that, and then make sure that you're accessing the one for your Python version. Okay, I'm using Python 3.10 at this moment. Yours should be a little more advanced. So look at the list of modules from A to Z by Python. Okay, so usually if you're trying to do something, you can just Google it. Let's say image. Okay, determine the type of image contained in a file or byte stream. So let's say we want to work on images. We'll see what Python has on image. Okay, so you do Ctrl F on your keyboard, and then you're able to do that. So I open this one in. Let's get another one about strings. Look at email package supporting the parsing, manipulating, and generating email messages. Fine. If I click on that, then you can read through and see what it really does and how to use it. You understand? So it's that easy. Those are modules for you, and they're not hard. It's just already written code, external somewhere, that you have to use. Now, some of those code, like when we saw this, you have to install it. Okay. Some of them, if they're external, you have to install it using pip. Okay, let's say this one is you'll be given instruction on how to use it, but let's say we have to install image filter. Okay, I'm using it as an example, not necessarily that it has to be installed. You go to your code, go to your command prompt and type something like pip command line like this. Go pip install, then you write the name of the file or the module. So after installing it, that's when you can have access to it from here. Alright, because it's external. It's not a part of your code, it's external, so you have to install it into your Python before you use it. So that's exactly what pip is, in case you ever hear pip. Now guys, let's treat a topic in Python called regular expression. Okay, so a new regular expressions. So regular expression is basically a Python, not just Python, but generally in programming, a way of finding things that match in strings. Okay, so if you give me a string like my name, Dave Partner, and tell me to count how many times D appeared in Dave Partner, a regular expression is the proper way of looking for that. What of how many times a white space appeared in the string? Let's say we wrote the big brown fox jumps over a lazy dog. How many times did the white space appear there? That's a regular expression is the way to do that. What if we wanted to change every occurrence of V in that sentence? Okay. And what if we want to know whether a string, you give me a string, what if I want to know whether it's an email? You know that an email address follows a certain pattern. For instance, real Dave Partner at gmail.com. That's my real email address, alright? It follows a certain pattern. There is a sentence here, not a sentence, but there's a word here that cannot have space. Okay, the word here cannot have space. The very first part, divided by an @ symbol. So there's an @ symbol in every email. There's always an @ symbol. And then there is a domain name here. Okay, and then there must be a full stop, and it must end with any of the endings for a domain name. So this is a pattern. So a regular expression helps you to find a pattern. So with a regular expression, if you gave me an email, I can write a little regular expression check that will tell me whether it's an email if it matches all these little things. Now another thing I want to tell you is that regular expressions honestly confuse many people. Okay, so what you have to do, whether now or in future, I'm just showing you regular expressions so that you know that it exists and get an idea of how it works. And then in the future, if you ever need to code anything in regular expression, just go to Google, find it. Okay, somebody has almost always written a code, a regular expression on that. Same thing with going to Stack Overflow. So let's say a regular expression for finding email. Search for Python regular expression for email. So say check if your email address is valid in Python. Somebody already written the code. What of all these addresses? 39 million results. Okay. So if you scroll down, you will see that this is the code here. So this is the regex. So this is how regular expression looks like. Okay, this is a variable, and this checks. Guess what's here? Remember I told you an email must have a set of words. That word must be capital or small letter A to Z. Okay, small letter, and can also have a number and can have a full stop or a dot, period. Okay, at the end of the day, it can't have a space. Then it has to have an @ sign, and then after that @ sign, there has to be capital or small letter and even number. That's the domain name, that's the Gmail part, and then there has to be a period. Alright, and then it has to have another one, capital or small letter. So this is regular expression. Then here this guy is saying define a function where you write passing the email. Okay, and then regular expression uses that regex. This is the email you passed into the function. Don't worry, we're going to write our own. I just want to give you a rough example. Alright, so the guy defined the function after creating the regular expression. This is like a pattern. Alright, then he says if this email passed here matches this pattern, it's a full match. If it matches this pattern, tell us that the email is valid, otherwise tell us it's invalid. So this is usually used like when when you create a form in your website that people will fill, and somebody can just come and type, hit enter without typing their actual email, your code should be able to tell the person, sorry, enter a proper email, and they will never know how it happened. It's because you wrote a single line that matches what an email should look like, and then use an if statement to check whether that email. Now you've been wondering, what is this RE? This RE is the regular expression module in Python. It is built into Python. We're going to use it now. Alright? We're going to use it. So as you can see, regular expression is simple. The only place that confuses some people is knowing what to write here. Alright? All this stuff. Like I said, if you Google almost everything you want to write a regular expression on, if you Google it, you will see it. But it's also good to have a rough idea of what all these brackets and plus signs mean. So let's attempt a regular expression at something. Okay, basic regular expression. To use regular expressions in Python, you have to import it. So import RE. The library is called RE. Okay. So now we've imported it. Now we can do something. Let's create a sentence. Okay, sentence that will say the quick brown fox jumps over a lazy dog. Okay. And now we can do a regular expression of it. So let's say R, that is RE that we imported. So we can access so many functions in RE, so many. Okay. So the one we want to access for now is search, to know whether a particular text we are going to pass in exists in what we want. So let's say we want to count how many white spaces are here. How many white spaces? So we're going to do backslash S is for counting white spaces. How many white spaces are in sentence? Okay. So basically that's it. That's just how to do it. So invalid escape sequence S. Okay. What we can do here is to do print. Okay, let's print every time S appears here. So do like this, and then print. So 6 times. There are 6 empty spaces here. We'll say, let's count it: 1, 2, 3, 4, 5, 6. So why is it giving us 6 instead of 7, 8? Why do we have 6? Got 6, which is a weird number because we're not running the correct file, so we have to run this file through here and the regular expressions, and then we run. Alright, so it's giving us an error. For some reason, it has a problem. Maybe this version of Python is having a problem with backspace S. Okay, so but let's try something else. Because is the backspace, it gives you the very first occurrence of a white space in a sentence. Okay, and it returns a math object. So this is an object, right? So let's look at this and interpret what is here. It says, give us the very first occurrence of a white space in this sentence. Okay, what's the first occurrence of a white space? It's here, right? So let's count. 1, that is the first character. 2, second character. 3. Alright? So between character 3 and character 4 is where the first white space occurred. So that's why you're saying this. It says span between 3 and 4. And what are we looking for? A white space. You see? Now, what if we switch this to find all? Find all. Search. You see, it gives us all the occurrence. Alright? Gives us a list that has all the occurrence. So if we count this now, you'll see that it will match this whole place. Alright? Highlighted all the places that this an empty space occurred, and gave us a list of it. So now it's in a list. We already know how to manipulate lists, right? So how do we count this number? We just do len, right? Wrap everything inside len. Since it's a list, the len function will work, and if we click this, it gives us 8. So there are 8 spaces: 1, 2, 3, 4, 5, 6, 7, 8. Alright, so another thing we can do is to find the first occurrence. As usual, if you're wondering where I'm getting all these things from, okay, I'll show you very shortly so that you'll get an idea of how many things you can and how different, how many manipulations you can do here. So, but first of all, let's find if this string, so we're given a sentence, let us find if it starts with this and ends with this, okay? So the way to do that is to write search. So search the string and see whether, pay attention, whether it starts with this up arrow, okay, that is above the number 6 on your keyboard, okay. So find if it starts with THE, alright, and continues, and find also if it has, it ends with dog, okay, and this dollar sign is for ending. So we want to see if this string started with the word the and has a lot of things and then ended with dog. Alright, so now we found out that, yeah, what if we want to create give a better what do you call it, message. So initially here we want to give a better message. Instead of printing X, instead of doing print X, you know, it will always give us an object. That's just a mass regular expression. Always give us an object. In the object it says that yes, there was a match. Alright, and the match was between character 0 and character 40. This is character 0 and this is character 40. Okay. Now what if we want to give a more beautiful message? Instead of printing X, we can just do an if statement that says if X, okay, this is the same thing as saying if X is true, capital letter true. Alright, so but in Python you wouldn't do that, you just do if X, okay. If X print yes, it contains that, and or no, it doesn't contain. So we can just do run. It says yes, it contains that. So that's how you check things like that. Now another thing we can do before I show you a list of all the regular expressions and things you can do with them. Another thing you can do is to check what if we, instead of saying the, we do quick. Okay, what if we did quick? Now can you guess what's going to happen? Just run and boom. So sorry, it doesn't match because what it doesn't start with. So what if we change this and say yes, it contains that? You see? So that small arrow ensures that it must start with it, and if you don't want it to start, you can remove. Alright? So that's a regular expression for you, but if you want to learn more, which I advise you should do, just go scan through, read through, scroll through the page to get an idea of what's possible with regular expression. Alright? So you go to W3 Schools. Of course, there are other documentations, but I think W3 Schools website is a little more organized. Okay? So you go to W3 Schools, regex, and then you read through under Python. Just go to W3 Schools, search for Python, the way we did it, okay, before. Let me even do it again. So you go to W3 Schools, Python. That's what you search for. And then you click. Okay. Then you go to regex. Then you scroll down to regex. And click. Then what do? You go through the page. So all the characters you could use, you see, the one we just used now, it starts with. Alright? So this is a table containing all the characters and what they could do. So just read through, you don't have to know everything or remember everything. And these are examples, alright? So sometimes in interviews, you're given a regular expression assignment. In interviews, yeah, practical interviews, they'll tell you, check, they'll give you a sentence, or they'll give you an article and tell you to write a regular expression that finds the how many matches, how many times XYZ matches there, or a certain keyword matches. So this is where you will use to find out which words, which characters to use in your regular expression. Okay. Now there are special sequences. We used S to find space, right? Small letter S, but there is also a big letter S. Big letter S is like the negation of small letter s. It means does not contain. Okay, if you use capital letter, or if you use small letter, it shows contains. So you look at all these special sequences. Then you look at sets. Remember we saw the first example we saw with respect to emails. Somebody did A to Z and A to Z. Okay, returns a match of any character alphabetically written. Okay, so you look at this, read through it and see what's there, and then you see find all. Now there are 4 key functions in Python regular expression. So at the top here, you will see the 4 functions. Here you have find all, search, split, or sub. See what they do, and then till you get to the bottom. So just reading through this alone gives you a rough idea of what is very possible with Python. If you want to write the codes manually yourself, you can do that. So, but this is what regular expression is. If you ever run into a problem tomorrow that you need regular expression, now you know how to find your way around it, and where to find the documentation and how to resolve it. And like I said, almost every problem you're going to meet in regular expression, somebody has written a cool working code on it. So you just go to Google, search for it, and then you'll find it. Let's talk about classes in Python. Remember we discussed, we said that lists, when we were discussing list arrays, okay, in Python there are no arrays, they call it lists, but it's essentially the same thing. We say that an array or a list is a type of variable that can contain other types of variables. You can put integers, you can put strings, you can put floating point numbers and everything inside it. Okay, so now imagine a class. A class is like a very big group of both all types of variables, arrays, and then even functions, even other classes. So consider a class to be a like a large container that contains things. But then, very importantly, what it contains is just a skeleton of what is to be done. So look at this. This is what a class looks like. Basically a framework of what a car should look like, and then you can print multiple cars out of it. So a good example is a production line. Have you ever been to a company where there's a production line, and consider that whole warehouse a class. Okay, the whole warehouse where they produce the car, a class. And then usually where they produce cars, there will be a railway inside the building. So the car is being pushed through the railway, and each department adds something to the car. So the first department might put the engine, and the second one will put the tires, and they keep pushing it through the railway, and the third one is going to put the roof, and then finally the last one paints it, the next one drives it out of the building. Okay, so that warehouse means cars, and it can mint different cars by just changing the color. The paint section can change the paint color, the wheel section can change the wheel size, and so on, and then different kinds of cars will be coming out from the building. So that's what a class looks like. Another example is a human race. So the human skeleton is the same, alright? The average skeleton of a man of 40 years is the same, right? But then, by the time you start adding skin color, hair length, and speech mannerisms, and a whole lot of things, you see that you build a different human being out of each skeleton you come out with. So each skeleton is like a platform, a basics of what the human being should look like, and then you start adding other features, alright? Okay, so let's try and do some basic coding in Python. Now, it's very important that you understand this concept, because you'll be using it a whole lot in your Python programming. And of course, at the end of this tutorial, some of these concepts that we've covered might just be a little hazy to you. You just get a general idea. It's a perfect way to feel, because when you start building real apps with Python, alright, probably in subsequent tutorials, it will all start making sense. So for now, to understand what a class is, what an object is, what inheritance is, okay, just those 3 or 4 keywords. Alright, so we're going to create a file, and when you want to create a class, in almost all programming languages, there are general conventions. Number one is that the file name should start with capital. Alright, in this case, let's create a class for a car, alright, or human, okay, we'll call it human.py. So if you are working through, if you are looking through a folder structure of any Python app, or any other Aperture and you see a file that starts with capital, most likely there is a class inside that file. Okay, it's just convention. It doesn't mean you can start your class file with a small letter. Then another thing is that it is advised that if you're going to create a class inside a file, make sure that the name of the file matches the name of the class. So here, let's create a class and call it human. So this human is going to serve as a container and a toolbox for us to mint new humans. All right. Now, another thing you need to take note of is that what am I saying? Okay. Another thing you need to take note of in Python classes and classes in general is that you should always try to create just one class per file. Okay, one class per file. So this file now is going to have a human class. If we want to build a Caucasian class, for instance, we need to create a new file for it. So it's just general convention. In most programming languages, you can add multiple classes in one file, but it's not advisable. It just makes you a bad programmer. Okay. So we've created a file, and let's define a variable inside it. Let's say first name, first underscore name, equal to Dave. Okay. So that's how we roll. Okay. So let's create a file another file to read this. So let's say create a new file. What do we call it? Okay, human practice. This name doesn't mean anything, I'm just writing. So to use this file, we have to import this class, okay? So import human. Okay, this is, we are importing the human class, the human file. Okay, but then we also need to import the class inside, okay? You've seen before, you already know how we're going to do it. We're going to do from human import human. So the first human here is making reference to the name of the file. The second one is making reference to what's inside the file, which is this human. Okay. So now we import it. We now have access to this class. We can access the property. So in a class, these things are called property. Any variable or function you declare there is called a property. Okay. So here we can, you have to instantiate the class. Okay, the instantiate is to create a copy of the class, and then you tell it what should be inside. So here's what we're going to do. We're going to create another variable in this our new file. Now we've imported the class. We create another variable in this our new file, and what do we call this variable? Let's say, let's call it variable x, just for lack of what to call it. Okay. So this is a copy, this x, let's make a copy of this class. We'll say human dot first name. Alright, now we can print x. So make sure we run this, where is it? Human practice, good, and we run. And it prints isn't that amazing? So here we had access to this class, and then we had access to its properties. Okay. So this is called an object. Okay. An object. Object of the human class. I'll let you know shortly what objects are. Objects are basically instance of each class. So this class helps us create humans. We are going to add more features to the class, but it helps us create humans. So for each human we want to create, we'll create an instance of the class and then define the new features of the human. Long hair. Let's say the first object, we'll tell it that the human will have to have a long hair. The height should be 5 feet. And then the weight should be whatever, body weight, this, that. And then we want to create another human, we create an instance, which is an object of that class, and we start all over again and say that the height should be 7 feet this time, the hair should be short, the skin color should be light, and so on. For the next human, we'll do the same thing and change the gender, just like that, okay? Alright, now we've seen how we can get information. Let's go to the human class and do more things. Okay, so I'm going to delete this, we don't need it. So the thing with Python is that if you create a Python class, and generally in every other class in most other programming languages, there's usually a function that has to run first. Alright, whether you have 1000 functions here, you can have 1000 methods functions, okay? And but then whenever this class is instantiated like here, Python gives you the opportunity to create a class, a certain function that must execute. Once you instantiate it, that function must execute. So sometimes when a class is being instantiated, okay, hope you're getting what I'm saying. Instance, okay, so instantiated, okay. So when a function is being instantiated, alright, when a class is being instantiated, you want a certain function to run, okay. Sometimes maybe you want every time a human class is called, you want to set certain variables, assign certain variables to certain things before the user can start using it. So that function is usually called a constructor. So most programming languages will allow you to name that, will force you to name that function a constructor. Every other function you can give any other name, but that particular one that must run first, you name it a constructor, okay? But in Python it's called init, okay? So we go, and we have to do def, because we're trying to create a function. We do double underscore init, and double underscore again. And it's already telling us what it is, you see? So here, we can start doing things, okay? Adding things inside this function. Now, one thing I want to let you know is that in Python, specifically, unlike other programming languages like JavaScript and PHP and stuff, in Python, the init class must have a parameter by default called self. Okay, so you must add this parameter and you must have self, whether you're using it inside the function or not. Okay, so if you want this function to have other parameters, fine. Okay, you add them as the extra parameters, but the self must be there. Okay, so let's add other parameters we might be using. We need a height, we need skin color, we need what else? Hair length. Okay, what else do we need? Skin color. Let's leave it at this, so we don't have too many things to worry about. Okay, so inside this function now, we have to start assigning. We can do self dot height equal to height. So anytime this function is called and somebody says this function dot height, that it should be the height that is passed in here, and we'll do the same thing with self dot skin color. You know, some people would rather put an underscore here, an underscore, or the other way. Some people will put underscores here. Why are they putting underscores? So that you know which you can differentiate between them. So here I can do this. I think it makes it easier for you to understand. Underscore skin color, and then self underscore self dot underscore hair, self dot hair color or hair length. All right, hair length equal to underscore hair length. Okay, so these are the three things every time somebody calls this class that we want to set. All right. Go back to our human practice Pi and try to do something. We no longer have first name as a property of that. So now we have an init function. We can initiate this this class as if it's a function. Look at this. If you're looking at just this, you'll think it's a function, but it's actually a class. And the giveaway by convention is that it starts with a capital letter. Alright, it's the capital letter that tips us off that this is most likely a class, okay? Otherwise, it looks exactly as if you're calling a function, alright? So the first thing we do is, Python already tells us, the PyCharm will tell us what's inside the function. So the first thing we need to do, let me recap it so it kind of guides me on human. Okay, it tells me things I need there, human height. That is underscore height, underscore skin color, and hair length. So the height we're going to put is 6 feet, skin color we're going to put is black, and hair length we're going to put is 22 inches. So we've initiated one class, so I have to put the spaces because of Python. Okay, so we've initiated one class. So first of all, let's try and print just X and see what happens. Just print X. It gives us an object. Okay, But let's say we print here x dot skin color. X dot skin color. It gives us black. Hope you understand what's happening now. This dot skin color is this. So it ignores this self here, right? The self tells it to ignore and just merge human dot skin color. Alright, it gives us the skin color, and what skin color is that? We already told it on this instance. Do you know we can create another instance? Let's look. Let's say y equal to human. We'll say 5 feet 5. White skin, and hair length 3 inches. You see, now we can print x dot skin color. Let's print again. Oops, Control D or Command D to duplicate. You can do y dot skin color. We'll run, and boom, black, white. The skin color of the guy is black. And we can add more things. For instance, y dot hair color, hair length. That's common, right? There is a problem. Skin color. Oh, mistake. Mistake. Okay. You see, white and 3 inches here. So it gives you an idea of how you can use these variables. You know, we can do a lot of other things inside this. For instance, when we imported array, right? Regular expression, when we did array like this, or when we imported math, or when you import things, just know that those things you imported is a class. So when we did regular expression, when we did that find all, now you see that this find all is an attribute of this class. So if we go into this class, this find all is most likely a function. Alright, a function that was created inside this regular expression class. So that's what we're trying to replicate, do it on our own, and that's just how to create class. So with this now, we can mint any unlimited number of humans, okay, with different features, body features and body types, but they all have the same kind of things. Alright, so I hope you now get what a class looks like generally. Let's do something that increases the height of this person. So let's say we're building a game and somebody achieves a certain point. We want to increase the height of this person. So let's first of all start with x.height, just to see what the height is. I'll delete this. Okay, we print. We already know that x.height is 6 because we passed in 6 here. I'll run. I'll say 6. Fine. So how do we increase the height? Let's go to human class and create a new function. Okay, new function def, and we can call it increase underscore height or whatever, and create this. You see, Python automatically adds self to it for me. That's the way that Python works. I'll hit enter, and then I'll do self dot height. Okay, whenever this function is called, self dot height should increase by 1. Remember, this plus equals sign is a way to take whatever is here, add 1 to it. Another way we can do it is to say equals to self dot height plus 1. Alright, instead of writing this long, we just do plus equals. Alright, plus equals 1. So every time this function is called, it takes whatever is in the height and adds 1 to it. So let's go there, and we'll print height first. Run again, print height says 6. So let's call that function. So what if we do x dot increase height? You see, we call the function and then we print x height again. Okay? Print x height. Okay. So let's see what happens here. It says 6 the first time. All right. Now we run the increase height. It says 7. Okay. What if we run it again? Increase height. Guess what it's gonna print? Print. There's 6, 7, 8. So remember that this increase height is working only on x, because if we print y dot height, it will stick to 5.5. Okay, y dot height sticks to 5.5. Okay, no matter how many times you increase x, y y stays unincreased. Okay, so this is basically how classes work. Now let's do something else called inheritance. Let's create, we have a human class here. So let's say, let's create a black. Alright, I'm black, so let's create a black class. Black.5. So it is possible to inherit the methods. So the properties of this class. So the first property is this. Okay, there's only one property we created here. Alright, so we can add more functions that does more things. For instance, change color, depth, change skin color. Okay, we can see self.height. Here we can say give us new skin color. Okay, self.skin color equal to new skin color. Whatever. Okay, of course by now you know how we're going to use this. For instance, if we come here, we can say, let me delete most of this. Let's say x dot change skin color. Alright, we can pass the new skin color as yellow, then print x dot skin color. Now if you look at this code, you see that the first skin color we had was black for x, and now we've passed in a parameter yellow. Now why don't we pass in two parameters? Remember, it has two parameters. Why don't we pass in two? Because Python ignores this first one. It's just compulsory that you have to have it. Okay, so Python sees this as having one parameter. So here we have changed the skin color to yellow and we're printing the skin color, but I think we should print it first here. So we print the skin color. The first one should give us what? Let's remove height. We don't need it. So the first time we get black as skin color, and then we change the skin color, we try to print it again. Okay, let's see. You see it changes to yellow. Okay, good. So we now have two properties. So what if we create the black class? Where is it? Black. Can we inherit the properties of this class? Here's what I mean. So let's say create a class called black. Now if we want black to be able to do things that we already have here in human, things we already have here are all these. Alright, we already have all these here. So one thing we can do is to copy it, all of them, come here and paste them all over again, so that we can be able to use them. But it's boring. Okay, it defeats the idea of programming languages. So to use things you have there, you have to like import a class, say from human import human. Okay, so now we can start working on the black. This is how to create a class. But if you want this class to inherit from another class, you do what? Human. You mention that class inside. So now inside this class, we can access a lot of things. For instance, we can say change. We can do things like first of all, you can say depth. Okay, depth is a new function that does what? Depth that make fatter. Okay, so we can say self dot height, or make shorter. Yeah, good, shorter. Okay, self dot height equal to, we can do something. But what I want you to know is that we can now access all the properties inside the parent class. We can do human.increase and then do whatever calculation. So we can now access it because we are inheriting it. Alright? So that's just what it is. Nothing really too wonderful about it. Just know that one class can inherit all the properties and methods of the other. Alright? Including the init class. But if you define your own init class here, you will no longer, if you define depth in itself, once you do that, this particular black class will no longer inherit the init class of the human. Alright, if you want it to inherit it, you have to define a function called super. Okay, so when you say super means go to the higher class and inherit its own init class. So inside the init class of this one, black, what we want is every time black is instantiated, it will also instantiate the init class of human so that we'll have access to it. So that's just the thing about classes. Alright, like I said, when you start building real world applications, it will make much more sense, but nothing too complex about it. So finally, let's look at the Python interpreter. If you install Python in your system, it should have the interpreter along with it straight up, okay? But if for some reason it's not in your system, then there is a problem, okay? So how to know it is that I'm using Python 3, so you just type Python 3 on your keyboard and see whether it shows this. If it shows you an error, for some weird reason, Python was installed in your system but not included in the environment part. Mostly in Windows, that's where you have this issue. So you go to Google and say how to include Python 3 into my environment path. Okay, Google will just show you a line you have to copy somewhere and paste somewhere in your system, and it's included. But generally, you shouldn't have any issues once you install Python at the beginning, like we did. So this is basically the moment I typed Python, it's kind of opened the sheet for me. Basically, this place is equivalent to this place. So all the codes I can write here, I can write it here. Alright? The only thing is that it's just a single sheet. It doesn't know where every other thing is. So for instance, we can do print hello world. Hello world. That's for hello Python world. Okay? Enter. See, it prints hello world. So if you have a certain Python code you want to quickly run a test, or something you just want to test without having to create a file and save the file and then come and run here, okay, it's the interpreter on your command line. So you open a command line, you just type cmd on your start menu. If you're in Windows, just go to start menu, type cmd, and you can write Python code from here. You can do a lot of things like x equals to 2, y equals to 3, and we can say print x plus y. Enter. Let's make a mistake. Print x plus y. This is a mistake, syntax error. I did not close it. So if I hit enter, what does it do? It thinks I'm trying to define a function. So you can even define functions here. So when you're done, you press Ctrl C on your keyboard, and that's it. Alright. Now, if you want to exit this interpreter and get back to a normal command prompt, we'll type exit, and then we're back to a normal command prompt. Okay. And another thing is that it doesn't matter where you do this. For instance, I'm doing it inside a certain folder. It doesn't really matter. As long as Python is installed in your system, you should be able to easily run this Python interpreter anyway. Alright, and ladies and gentlemen, that brings us to the end of this tutorial. Don't forget to like, subscribe, and follow me on all channels. Okay, follow me on YouTube, on Udemy, and there's the partner. On YouTube, Brain10 Pro Tutorial TV. Follow me as I go into the next course where we are going to go much deeper into Python and build amazing apps and even machine learning. Alright, thank you very much. See you. Don't forget to be able to contact me if you have any issues, like agree with a partner, or you need any project that I can join. Feel free to reach out to me. Alright, so as usual, my email is therealfaithpartner at gmail.com. Okay, just reach out and then I'll be right there to help you. So congratulations on completing your introduction basics on Python. Now the next level the next course you want to take on Python should be teaching you how to build something with Python. For instance, how to build a website with Python, or machine learning with Python, or whatever. Thank you very much. See you.